All right. Hello, everyone, and welcome to my stream today. I am very, very excited about this one. I hope you all are too. All right. Yeah. And it's because we have quite the guest today. I've been a big fan of Dominic Gannaway's work for years and years, and I'm very happy to have met him over time, interacted with him, and learned from him. So to have him on the show today is a great honor, and I'm very stoked about that. So we'll have him joining us in a few minutes. I am just, gonna shoot the shit for a little bit while we make sure people join the stream. How's everyone doing today? Come say hi in the chat. Tell me how you're doing. I'm already into my orange juice. Jeez, I'm going a little too fast today. I am hyped. Oh yeah, I see you guys are hyped too. Yeah. How's it going, Greg? Yeah, good. Thank you for saying hi in the chat. Yeah, awesome. Yeah, Lexical. That's one of the things we associate with Dominic. What else we got here? It's so weird how I'm excited for this. Yeah, no, this is going to be really cool. Honestly, and one of the most exciting parts about this is, we'll see how it goes. It's pretty impromptu. The stream here. It's casual. So I just know that there's a lot to get into. When you look at really the last 7 years of JavaScript framework development, Dominic's had his hand in it. So it's amazing to hear that story. All right. How are you all doing? I think I should probably go on Twitter here and tell people that we're live. A lot of actually interest on this one. I mean, unsurprisingly, but we actually had a lot of people interacting with this tweet, hyping up the stream today. So thank you everyone who actually bothered doing that. Not repost, undo repost, quote repost. Sorry, they changed the UI ever so slightly in Twitter the last few months, and it always throws me off. I published an article today, and I'm glad I published it with the title and the text because they removed the title and links. I don't know, something new. But yeah, I guess they're experimenting. I wonder if their analytics are showing that these improvements are actually an improvement. Sorry, I never remember my Twitch. What is it? Twitch TV, right? Is it Ryan Solid? Chat can probably tell me better than I can. Good, people still coming in. Yeah, super pumped. Nice. Thank you, everyone, for joining. Are we going to reverse engineer Twitter? I don't know. I mean, who was that? The one guy came in and he figured he could fix Twitter in a week. I mean, can we fix Twitter in a stream? I don't know. All right, I'm going to post this here and get people joining in on the stream. All right. I know one of these days I'll have one of those professional looking pre-rolls, but today is not that day. Yeah, okay. I think I'm starting to get set here. George Hotz, yeah, that's exactly who I'm talking about. Yeah. Whatever happened to George? I don't know. I guess that's a rhetorical question. I don't know if I ever actually cared. All right, let's see here. I'm still just killing a little bit more time because if you know me, I want to make sure that, people are starting to show up now. All right, that's good. All right, I'm just getting set up. Just give me 2 seconds. But yeah, I mean, I want to ask the chat. Have you guys heard of our guest today? Yeah, you guys are aware of his work? Just signals and magic. That's what you're here for? All right. You you want to talk about Lexical? Yeah, that's the fun thing about this stream. Dominic has worked on so many significant projects that I bet you we're going to have people from all over the place wanting to hear about them. Yes, okay. Thanks, chat. Thanks for showing me that you're live. Yeah, thumbnail. I honestly, I think if you guys aren't aware, David made that thumbnail. Saul's community manager. He's been waiting for this one for a long time. I think he had this like already prepped in his head. I mean, he's going to tell me he didn't, and he just whipped it up in an hour because he is a magician himself. But like, he's been waiting for me to have Dominic on for a very long time. He was involved. He built obviously Solid's website, but actually, for people that don't know, he was involved in the Inferno website back in the day. So they go way back as well. So he was ready to bring his A game for the thumbnail, which is just amazing because yeah, it's probably the best one yet. It's got to be between this one and the bling one. So yeah, long time. Yeah. Hey David, how's it going? Yeah. Well, if you are Svelte people who haven't seen, Dominic's previous accomplishments, they're pretty impressive in their own right. So I hopefully you'll learn something on the stream as well. We're gonna hopefully tackle the whole gambit within time constraints. Me and Dominic can sit and talk shop for hours. We've done that, so we'll have to contain our excitement a little bit here for the stream. But yeah, no, it's good. I'm hyped. Even Lit has signals now. I mean, I'm not surprised. I actually saw something about them changing their template to do some pre-compilation. Yeah, we're going to talk about no build today as well a little bit later on in This Week in JavaScript. So, unless it comes up before, we'll see. But yeah. No, signals are almost everywhere. Okay. Yeah, they have a helper for Preact signals. Okay, have I been wasting enough time yet? Is everyone here hyped? Yeah? No. The chat's dead silent. I guess they don't care. I'm sorry. Maybe. Let's just drink some orange juice. All right, here we go. Okay. Let's go. All right. Okay. So, without any further ado, I'd like to welcome my friend Dominic Gannaway onto the stream. Welcome so much. Thank you so much.
Yeah, good to be here, and good to see so many people on the stream.
Yeah, come say hi in the chat, you guys. Yeah, no, it's awesome. You've been requested for, I don't know, almost since I started the stream. People are like, oh, we should have Dominic on and talk about Inferno or talk about Prepack or talk about Lexical or talk about whatever. So yeah, definitely very excited to have you on. I just listed off a few of the highlights of your accomplishments, but I don't know. I usually leave it up to my guests to introduce themselves a bit. So there you go.
Yeah, sure. So, I'm Dominic, and lovely to meet everybody. And I guess we can start my journey around the time of Inferno. But for those who don't know me, etc., currently I work at Vercel on Svelte. Busy, hard at work, making Svelte 5 a reality, and hopefully something that people will love. And yeah, that's kind of where we are now. And obviously you may have seen the runes post that came out a few weeks ago. And obviously our endeavor into signals, which is something that I've been quite passionate about. Not maybe as much as Ryan, but over the last year or so. And so it's been quite interesting taking the ideas and concepts and things I've learned over the many, many years working in this space and bringing it to Svelte.
Right. Definitely. Yeah. I was gonna ask you, yeah, because like I was very stoked to have you on board, on the signal side, because my first introduction to you was the guy who wrote the fastest virtual DOM implementation, right? Which is incredible. So yeah, I guess we're gonna find out how we got from A to B. But Can you tell us a little bit how you got started in web dev?
Oh yeah, so I don't know how many years now. When I was about, well, let me start from the beginning. When I was, say, I started programming from about 7 or 8 years old, and my first language was Visual Basic 5. My dad kind of like saw that I was interested in this game I was playing called Duke Nukem 3D, and it had like a map editor. And a map editor, you could set up very basic, primitive programming tools, and loved it, even though the game was clearly too young for my age group. Got into programming from there, and kind of enjoyed making games. I kind of really wanted to be a games developer, and then spent most of my teenhood hacking on building game engines and sort of multiplayer engines, and it went from Visual Basic into Java and .NET and C#, Pascal, lots of different languages. And along the way, I was enjoyed hacking and modding games at the same time.
That makes sense.
Like sort of RPG games and that sort of thing. I was really interested in that because there were games I could build like 2D graphics at the time. It wasn't like 3D or anything complicated.
We have an incredibly similar story on that side because my start was also wanting in game dev, specifically RPGs. I used to play in like .NET and C# and like originally before that C, but like trying to build these RPG games towards I guess the late 90s. What kind of RPGs did you like back then? Like what was your...
My favorites were Diablo, Diablo 2. Legend of Mir was another one that was quite popular too. And yeah, I just enjoyed that sort of thing. I also enjoyed like RTS games. I enjoyed Warcraft and Command and Conquer and that sort of thing. And Civilization was another one that's popular in my house.
Yeah, I love Civ. Yeah, no, I think I was more on the JRPG side, but yeah, Civ was on the PC game side. My uncle showed me that. He was an engineer, and he, funnily enough, and he was like, showed me that, and he played it over and over again, and I got hooked for several years.
Yeah, no, I definitely feel you there. I also played Renegade, Command and Conquer Renegade for many years too, and that was quite fun. Even though it was non-RTS, I was sort of FPS, but that's kind of like my childhood, and I ended up going to university in the UK. I forgot to mention I'm based in the UK, if that wasn't already obvious, and studied computer science. And when I was there, I kind of, as my sort of final year project, built a full sort of like RPG multiplayer game.
Nice.
In .NET XNA that was full of Pokemon, but like with our own graphics and stuff. And what's interesting was I didn't want to do the documentation for it, which was like the majority of the degree. So like I coded the entire thing, and my housemates who worked on it with me did all the documentation. So that was our compromise. We ended up getting pretty good scores in the end from it. So that's quite fun.
Nice.
Along the way.
Yeah, I remember XNA. That was like they tried to build a bit more of a framework around it, because I remember using like DirectX directly was like a pain of like super long name dot super long name dot super long name as you're trying to like pull out all these DLL stuff. Anyway, sorry, I tangent it. My bad. Just let's continue. This is very just nostalgic for me.
Yeah, and actually one game that you can kind of see that I never finished, but I kind of started. I even got the trademark for, was called iHacker. So it was a hacking simulation game that was meant to be multiplayer. There was another game like it called Uplink, and so that was kind of my thing. And if you go around YouTube today, you'll find videos going all the way back from then. And I rebuilt the engine like 7 times in different sort of like languages and different like engines, and that was kind of, that's where my sort of introduction to performance is, like building game engines and tuning, because I had a netbook. I couldn't afford anything more. I was a student, and so I had this really basic netbook, and I had to run all this like sort of hardware and software like properly in it. And then that was where I kind of took a deep dive into building my own game engines. How could I get the best frames per second, and how do I get the memory down? So that kind of stayed with me for a while. And then once finishing university, I quickly realized that there was no work in the games industry. It was like terrible pay, long hours, and I had a kid on the way as well, so like I had to like kind of buckle up and just get a job that paid and got me, a food and a house above my head, sort of thing, So I jumped into sort of the web dev industry, working in PHP. Back then, there wasn't really much JavaScript other than, sort of like I think jQuery had just about came out. It was before jQuery. That was the time period, and yeah, that was kind of what we did. Building websites for different brands and agency stuff, and I did that for a couple of years. And then after that, I kind of delved more into JavaScript and sort of less of a toy language, because before that I played with action scripts and other things, and
Right.
I much preferred the sort of formality of using .NET and Java and more sophisticated languages at the time than JavaScript. But when I saw that what was possible with JavaScript, and also what was happening to the language, that more was coming to it, then I kind of took a big interest and actually took a job working in a fintech company specializing in sort of JavaScript web application development.
What time period is this about? Like what year?
This would have been about 2014, 2015.
Okay.
But yeah, about 2014. So what was interesting there was that they were building applications for banks and for sort of that sort of clientele. And a lot of it was building trading applications where you have very quick UIs showing prices changing and ticks and everything like that. And it was on mobile as well as desktop. And so that was insightful. And at the time that was powered by Knockout. So that was a good experience with using Knockout and using Knockout templates. And there's a
Knockout, nice.
sort of like backend that was written in a mix of C++ and C and Java. Yeah. And the front end was obviously JavaScript, and we had our own huge framework that powered it all. And these banks trusted what we built. And it was there that we kind of, I guess I kind of explored open source for the first time as well. Like really I always wanted to contribute and build stuff, and I had always done that, but I was always too afraid of sharing it, in the fear, I guess, imposter syndrome, that somebody would look at my code and oh, you're terrible. What actually was really interesting was I built a library called T7, which was a tag template library that would take your tag template and convert it to JSX or React.createElement. And I thought it was amazing because at the time we couldn't use JSX at work because we didn't have the build tool in there. There was the reason at the time. And I kind of wanted also to show a library that I could build. So I built that. And then I think a week later, Dan Abramov tweeted how terrible this library was on Twitter. And I'd never known about Dan up to that point. I was like, who is this guy? Why is he saying this for? And that kind of got me inspired of this guy's not going to shoot me down. I'm going to try harder and make this.
What, do you remember what his complaint was about it, or?
I don't think it was a complaint. I think it was more this is why we don't need this. This is why we need JSX or something. But it brought attention my way when I wasn't expecting it, and also kind of got me excited about this sort of thing. I didn't. The imposter syndrome kind of wore out. I saw myself as oh, I can do this, And so yeah, I kind of from there decided I want to build a faster React, because at the time I think it was React 0.14 or 0.13.
Yeah.
And it was not quick, especially on mobile. No. And we were building trading applications, and it was quick enough, but it was still noticeably slow for what we wanted. And we just came from Knockout, and I had promoted this whole change over to React, and I just saw an obvious opportunity to make this faster. So around that time, there was sorry.
Yeah, I didn't mean to interrupt. I just wanted to stop there for a second. We'll continue on that thought. I just wanted to ask you, so what motivated? This is just important for me, at least. I care about this. What motivated the move to React from Knockout in the first place?
The templates were terrible. The two-way bindings were causing a lot of issues and bugs. Testing them was difficult, and also there was there was a combination of things. I can't remember fully all the things there were, but also the company just wanted to leverage newer tech and do more, with what they had. Sorry.
No, continue.
There were lots of ideas going around the company about how we could modernize and it wasn't just React as well. It was at the same time we had all this other sort of tech debt and legacy code they want to modernize. So the idea was, whilst we were modernizing that, this is an opportunity to also bring in React, because the company doesn't really change that often. It's not every year they change their framework. It's every 5 years. So if you're going to change that at the same time, you might as well update your sort of front-end UI stack as well.
Do you remember the first time you saw or heard of React? What your reaction or thought of was around it? I'm just curious.
Yeah, I was hesitant at first to some degree, but I did try and play with it. I did actually really like the idea of, and I think it came from a game background engine, but like having this sort of declarativeness around a UI, and either you throw away and like start again the next sort of cycle. That kind of
Right. What is it called? Immediate mode
yeah.
rendering.
Yeah, and like it always occurred to me, it's like double buffering. Like you keep doing that, and then you then commit the one that you want to stabilize onto the screen. That's how I thought it worked at the beginning. So I was like, oh yeah, this kind of makes sense. And obviously it didn't work that way, but like it looked good. And I like the idea as well of sort of encouraging people to treat that as like a safe space that your render can be pure and you can sort of go through that way. And that kind of that's why I built Inferno. I was like, this is actually quite good. Some of the ideas are really impressive, and obviously it worked for Facebook, so there was some form of validation there that it was good.
Right.
Um,
Right. So Dan Abramoff calls you out. You have some respect for React's like design pattern. You're going to build a faster React. How does that
yeah,
go?
it was originally called System or Core JS or something. I called it before it was called Inferno, but it was just like it was my implementation of Virtual DOM. At the same time, there was a set of like framework sort of virtual DOM benchmarks. I think it was called the virtual DOM benchmark by Boris Cool, who
Uh,
uh, so he was kind of like
do you
um,
do you know how to pronounce his library? Is it Eevee or
EV.
Ivy or Ivi
I
or?
call it EV, but it could be called IV as well.
Okay.
I mean, what he did quite a few libraries back then, and also he was quite encouraging the scene. He obviously pushed these benchmarks out. There was another guy called Joel who built a library called Ceto. And we met up in London at one point whilst he was visiting, and we just kind of came up with ideas on how we could build this sort of perfect library. And it was kind of funny because that's when we actually did template cloning. This is all the way back in like
Yeah.
2015 or something. And so lots of ideas then were like, how do we optimize? V8 at the time was in Crankshaft, so it wasn't even using Turbofan. It was an
Right.
old sort of JIT compiler they used at the time. So it was all about optimizing for that, and I'd always take like the V8 output in bytecode and just like decipher it and figure out where the deops were and go through it and so that was it was a very interesting journey, like figuring out how to get the best performance, figuring out how to do things intelligently, and
Yeah. Because Crankshaft was like, I remember that time period. Optimizations seemed nonsensical. Like it'd be really optimized in one specific path, and then other ones you like completely. I know engines always have that problem, but Crankshaft, like it never back then. It never felt predictable. I feel like with Turbofan, they kind of generalized stuff in a way that's at least more sane. I don't know. Maybe that's just me.
yeah, I mean there was I forgot his name now, Benedict, who worked on like the V8 team at the time. Um, I'd always ping him and say, look, this is something weird is happening here. Like, I have an object literal that has 8 properties, but as soon as I add 9 properties, it gets de-optimized. It's no longer monomorphic. And he'd be like, let me check. He goes, oh yeah, sorry, we had like some arbitrary number or something, and we've just increased it to 64. And then like all of a sudden, like it would be faster, to do things. And I guess also what helped Inferno over the years was it was put into the speedometer benchmark, speedometer 2, I believe it was called. Now, I know they're building speedometer 3 now, but back then that was kind of like a good way of getting your framework optimized by the browser and VMs, because if it was in that, that's what they use. They didn't track all the other metrics, but if it was in there, there's a good chance they'd figure out how to like make it quicker. So over the years, although Inferno was never really being developed by anybody, it was maintained by the team when I left it, but it hadn't really changed so much.
Yeah.
But it was continuously getting improved by the different browser vendors because it was inside that benchmark. So, that was quite interesting to see there.
Yeah, so yeah, no, which is amazing. I did notice that, and over time I've watched Inferno. Was it last was about a year ago? I feel maybe 6 months ago. Like the JS framework benchmark slightly changed the way they were doing some measuring, and that over time Inferno, even though the code basically hadn't changed, actually basically just caught right up with Solid and some of the other ones, just simply on like over time it's been getting faster without the code changing, which is pretty cool to see. But when you went, I'm just kind of going back now to when you first created Inferno. So you set out to build this faster React essentially. Were you concerned about API like compat, or were you just like, I want to make a fast VDOM and just try and cater to it the best I can? Like, how
Yeah.
did you approach this?
Well, there was a lot of things actually. So initially, it didn't have the same API. It had sort of its own API. But I saw there an opportunity to basically the tooling in the ecosystem had changed. There was easy ways now of hooking into Webpack, Browserify, and basically saying if you import React, you can change it to be import this other module instead. So I thought, why not do that? You know, make a compat library, and then you can just change your Webpack config, and you can load Inferno anytime you learn import to React. And then what we did then was we ported over all like the React tests that were relevant and made sure we've passed through all their tests. It was interesting at the time because Preact had done the same thing. They were going after this compatibility, but they didn't bother importing and validating against the tests. So when we didn't get past all the tests, we were never fully 100% compliant. And that's because we made specific decisions not to. So we implemented like part of the synthetic event system that was
Right.
We didn't implement it all. So there were things like that were differentiating between the libraries, but Preact didn't implement it at all. So if you had unchanged, then there was weird hacks why it could work there, but it wouldn't work properly with all the weird things they do. And there were other events too that it's mainly the event system that things differed for.
Yeah, I'm very familiar with that event system. What do you call semi-synthetic event system was what Solid ended up adopting, and it was directly from looking at what Inferno does.
I ended up rewriting that event system when I was on the React team, which we'll get into later. So that's quite interesting.
I would have. So yeah, it wasn't you just wanted to do performance, and you saw a free win if you could potentially make these things align from a like API standpoint, get the test path.
For me, it was a bit of fun, and I didn't expect it ever to take off. I posted a link to Hacker News, and then I went out like to a nightclub that same evening, and woke up in the morning like oh, where am I? What am I doing? And I looked at my phone, and it had like the repository went from 500 stars to 10,000 overnight.
Wow! People were clearly looking for a faster React,
and we had probably like 200 open issues overnight as well. Like I was like, what happened there? It's crazy. And yeah, it was suddenly gained like a few thousand followers on Twitter overnight too, when I had less than 100. So it was kind of weird how overnight I got all this exposure, and I was like, oh, maybe I should invest more time into this.
Hacker News, eh? It was funny because this comment came in earlier when we were talking about imposter syndrome, about having the guts to even post to Hacker News, and I did not realize that you made the post to Hacker News that caught Inferno on fire originally. That's pretty cool.
I made a good logo. I think that helps. A good logo. We had lots of compliments. People like, who designed your logo? I was like, oh, I did. Just hacked it up one evening in Photoshop. But no, that was, people liked the name, people liked the logo, although the naming thing came in next. So obviously we blew up on Hacker News and Reddit and what else. And then like all of a sudden we're getting like emails from like the InfernoJS community, like requesting we change the name because there's too much. We've obviously taken their name. And somebody even sent me a fake DCMA takedown notice email, which I got checked over, and it was like completely like just from someone trolling me. But yeah, they were angry. They were like, why you can't use this name and you need to change? And I was like, why? But we're a JavaScript library. That has nothing to do with your operating system, It's like, but yeah, we kind of, I didn't do anything about it. It just kind of like settled itself. But that was my first like negative experience, I guess, because I was like, oh, it's positive so far, and then the negative comes, and that was the thing that kind of scared me off a bit, because I was like, as a sort of framework author, I can either pursue this and keep working on this and try and get a gig somewhere working on Inferno full time, which kind of could have happened potentially. After working for that company, I joined Tesco, which is a large sort of UK based grocery store, a bit like Walmart in the US. And like a lot of, we weren't working on Inferno there, but there was like, ideas on how that sort of thing could potentially happen in the future. There were also other places that were interested. I got reached out by Netflix at the time, and they were like, hey, come work in Inferno full time and work for us. So, but I also didn't really like the exposure to some degree. Like, I'm not a very public person. I kind of enjoy sort of the technical side of things, or like the sort of intermediate side when you're with a team, and that's where I kind of do my best. Not like trying to be an influencer or like some kind of like public person, you know. So
Right.
I kind of like, the negativity from that kind of was like the demand, you know, the request to fix something quickly, you know. Um, and what was annoying as well, and kind of embarrassing, was our biggest user was a Brazilian porn site. And he had his development team create all his PRs and issues, but he continuously sent us bug reports with links you'd open, and you're like, oh my god, what have you sent? And it'd be like, look, like there's a bug with like some DOM node that isn't correctly placed, and there'll be like all these images around it, trying to figure out. It's very distracting. So like, you know, that was kind of another side that was like kind of crazy as well.
Oh, wow. Yeah. This is definitely lots of fun. Yeah, I mean that's the thing with open source, right? Like the copyright thing was something we were worried about too. Actually, that's why we were interested in what you did about Inferno, because it's like, how easy is it for a name to be out there? And it's like, are you gonna go put a bunch of money in to like try and get some kind of legal protection of this stuff? And it's like, there's like this whole other side of open source that isn't obvious when you're the guy writing the library, but then suddenly when people actually use it, there's like whole bunch of other stuff you have to worry about, governance models in the community, to like, you know, yeah, guidelines and all, you know, all this stuff. And then yeah, to boot, you know, just all the, you know, the users you now have sitting there who can just knock on your door at any time. But I think what a lot of people probably want to know, and I kind of curious about here, is like, at first I was thinking like about talking about performance on Inferno, but I think people like there's what makes a framework fast is a lot of small things, maybe not one big thing, right? Like what made Inferno so much faster in the competition at the time? Could you summarize that, or is this just you know?
Um, yeah, I mean, I can summarize it. Yeah, I don't think it was even the fastest, to be honest. It was probably neck and neck with Boris's
Easy.
library.
Yeah.
Um, so I put it down to like maybe 4 or 5 different things. So one of the things is when we created the virtual DOM, as you would call it, the object structure that represented your DOM nodes and the template, we reused that. So that would be the same thing that encapsulates your state. So we wouldn't create another data structure there. So that meant way less allocations.
Was that done via, like, I know you have a custom JSX compiler.
Yeah, so that plays part of it. So that's the next thing, I guess. But like so when you have like create element out, we would like store the DOM node on the create element sort of object, if that makes sense, rather than create another tree that you then traverse through and put that in. There were complications around keys, like lists where you have keys, because React has an implicit key where if you don't give it a key, it kind of derives a key from the ordering. The next thing we did was we had a custom JSX transform, which ensured that we weren't creating create elements per se. We were creating objects that had sort of flags, bitwise values that avoided us having to do lots of nested if statements. So if you imagine like having type div props and some things like that, you then have to at runtime go through and say, is it an array? If it's an array, how many items does it have? If it has items, what do you do with it? Is it text? Do something with text. The bitwise thing meant the compiler or the Babel plugin could say, hey, this has no children, it's a string, that's all. And then bitwise values, like entropping them at runtime, is a much faster way than doing instance of or is array or type of checks. They're actually quite expensive to do them. They become quick when the inline cache kicks in, but that's if the inline cache kicks in, and a whole bunch of other things too. So we were able to just like save a lot of like sort of runtime overhead by doing that. And I guess the other thing was we use a very optimized sort of reconciliation pattern for how you deal with lists of items. So the least subset of basically how you can move the DOM nodes in a list in the least possible DOM operations possible. I mean, it wasn't the least because there's always different ways of doing it. And also, it doesn't always follow that sort of schema because on the UI and the web, you don't typically do some patterns as much as others, you know?
Right.
So there were ways of like also further optimizing for common use cases, but that was kind of what we did. And we also did some other things. We had like a much cheaper version of Should Component Update that you could do it in line. This is prior to hooks, so we're using class components. And we also ensured every single object was monomorphic. So we used the same object for everything, one object. And it allowed the VM to basically use the same hidden class behind the scenes. And we did that. And also we never used classes or anything. We tried to avoid looking up prototype methods. Instead, we opted to have just functions everywhere. So there were quite a lot of compelling things as well. And they all added up. So when you compound them together, it enabled us to have really good performance.
Yeah, I mean, I remember, like, obviously the JS framework benchmark, which we all agree now is kind of past its prime, and the virtual DOM framework or benchmark was actually more probably indicative or telling of how things should be. But if I go back to even the earliest days of the JS framework benchmark, I'm trying to remember, was Inferno in it like right at the beginning, or it came in like a few versions, and it and Eevee or Kiwi, I think the predecessor, were like way ahead of the crowd for the time. I'm trying to see if I can actually find like the old round results here. I'm doing it a little bit off screen. Angular Preact. No, okay, Inferno isn't in there yet. Round 3. Sorry, I'm just share my screen for 2 seconds so people see what I'm actually talking about here. Because is this like the beginning of? Do you remember this old colored table? Yeah, here's Inferno, right? You can see how big of an impact this was. Like, these aren't sorted in order, but if you go back in the day, like Vanilla.js was all green. This is our baseline. Inferno was 30% slower on average, with a geometric mean. But like if you look at these other libraries, I guess there's this thing called Plastique here that was, actually somewhat in the range, but like a lot of the basically at the time, like what were you going to pick up? A React 1.84, Vue 197. What else we got in here? Like Ember 4. Yeah, I mean, we weren't as good at measuring things back then. Now Angular, what's Angular? Yeah, 241. But Inferno like jumped on the scene very much in front of the crowd, almost undeniably in these like on these kind of benchmarks. I understand that on the VDOM ones, like Boris's tests are more specific, but this kind of, I remember seeing Inferno and being like, wow, like it's almost like vanilla JavaScript. I have to ask, like, when you did this, succeeded at that goal, like, did you ever get around to actually like, I mean, you must have, because obviously you worked with Dan years later, but did you ever get around to actually like have that conversation with the React guys, and be like, when you're like how's like Inferno so fast, or are they kind of like already like, just made different choices, we're on the same page? Because like for me, this was very surprising when I first saw this new framework jump on, but I don't know.
Yeah, well, that's the next interesting thing. So if you fast forward a few weeks from the Hacker News and the Brazilian incident, then you come across a tweet from Sebastian Marboug, who was the tech lead on the React team at the time, and he was like, Inferno, I can't remember the exact quote, but it was like, Inferno is great. If I were to rewrite React today, I would do it like Inferno. And then we kind of ran with that. I was like, wow, this is impressive. Like, where's this come from? And then I got an odd invite. I got invite to a chat, sort of like live sort of event. It's like a mini meetup at the Facebook office in London. And because they had a small office there, and I went over and just kind of watched the talks. And at the end, there were like groups of like engineers. I didn't know anyone there. I was literally by myself. And kind of I was a bit annoyed actually. I was like, no one's really talking to me. But the peeps is good, I'll stick for that.
Nice.
And then I just kind of stood in a circle of these people talking, and somebody mentioned Inferno, like without knowing. Obviously, they had no idea who it was. And I was like, oh, cool, yeah, that's a good library. And they were talking about it, and it turned out that people like Christopher Chadeau and Dan Abramov, and they were like, oh, you look a bit like the guy or something. I was like, yeah, it's me, you invited me, do you remember? And then kind of got talking, and they were like, come back for Facebook, we want somebody like you to make React faster. So I kind of nothing happened for a while because like had just started a new role somewhere else, and I wasn't too sure if I really wanted to work at Facebook. I wasn't really sure. I guess the imposter syndrome kicked in. I wasn't really sure if I was good enough to work for a company like that. And all my interviews at that point had not been about like notation and linked lists and stuff, which I just assumed like the typical Google or Facebook company would ask. And I was like, that isn't the sort of interview for me. I like to like do live demos and build something for real and tell me if I'm good, sort of thing. So I decided like maybe I could do it, and then a recruiter hooked up with me, and I ended up interviewing and getting through the interviews. And bizarrely, I got pre-allocated to the React team. So that's like a special path. Usually you have to go to boot camp and you have to like find your team, but they kind of like, yeah, come join the React team, And I actually got interviewed by some of the people from the React team, which was pretty awesome too. So I had these interview questions and did well enough, obviously, to get through and enjoyed. And I guess, what was interesting was like, I always assumed I'd be joining to like make React like Inferno, make it faster.
So, like, you went through that process because they tipped you off to it, but did you guys like have conversations of much conversations ahead of time about that?
Yeah, actually, that's a good point. So Dan pinged me and would invite me over to the office like in the evening after work a couple of times, and I'd come up, we'd grab a coffee, we'd sit down at a table and get laptops out, and I'd be like, this is something you're doing wrong, this is something you're doing wrong, you need to fix this, you need to fix this, and like he'd go through and like take note of the things, and he'd explain why something was done a particular way, But the big thing was like they were in the midst of rebuilding React as it was anyway, and that was React 16.
Right.
It was a whole new architecture based on Fiber, the Fiber architecture. So the Fiber architecture was all about having this notion of like a Fiber graph that represents your UI and also represents the intermediate things in that UI too, like your components and your context, and the ability to potentially fork it and do things with it to enable asynchronous concurrent rendering, basically. So when I came around, that was what they were doing. And actually, I got involved in that sort of thing anyway. And so straight away, one of the things I did was I enabled flat bundles. So they used to ship like thousands of modules to NPM, and you'd load it in your browser or whatever, and obviously they'll be bundled, but like it'll be slow. So we kind of improved on that, and we improved a whole bunch of things and made it so you couldn't interrupt with the private things. So we got performance better. And I did a conference talk in Paris that same year where I talk about benchmarking. So one of the interesting things a lot of people don't know is the requirements of Facebook are very different from the requirements of your company or some other company. Facebook is huge. Like they don't have thousands of components. They have tens of millions of components. They don't have a few hundred developers working on it. They have thousands and thousands of engineers working on like these products, and it's in one repository, it's in one repo. So it's like a different kind of scale to what you typically are used to. So when you open up like a website that's from Facebook scale, it's like there's probably a good few thousand components being rendered on that one page. So a lot of that is actually spent processing user code, not framework code. So when I tried switching things out to using Inferno, and another engineer called Sophie actually did that just before I joined, they tried that. There were benefits, but they weren't benefits that you'd say are mind-blowing. Like the time taken to render will be like 900 milliseconds down to 800. But was it worth winning 100 milliseconds from changing framework versus going all in this new direction architecture that wasn't compatible with Inferno? So Inferno did things like I mentioned before, where it put like the DOM onto the actual virtual DOM itself. That wasn't compatible with this fully immutable data structure that could be forked and split. But like Git, it's about like Git branch and and Git rebase.
Exactly.
So that's where that came from. So instead of that, I thought, well, if I can't change the runtime without causing churn to the team, I'll go ahead and do the next bigger thing. I'll build a compiler that makes all your applications much faster.
We'll talk about that in 2 seconds. I just want to back up. We went through a huge amount of stuff just there, and I just want to back up to one question, because the thing that I always wondered about personally, and I know the answer because we've talked before, but I think that they might want to know, is when you joined Meta, did you have to, like, was it your choice to stop maintaining Inferno? Was that part of the deal? Was that a? You said before that you had some negativity with the open source side of stuff, and you're like, maybe it's not for me. But like, how did you make that decision? Like, how did that happen?
Yeah, so when I joined, I asked about the sort of process there, and I filled a form in that meant that it wouldn't become like IP belonging to Facebook, and it would still remain a separate entity. And they were fine with that. But
Yeah.
at the same time, I didn't want to work on something. I had to detach myself from Inferno so I could put everything into React. And at the same time, I felt like um, Inferno was always going to be niche. And if I could take the things I learned there and bring it to React, that I could affect the majority and give everybody the same sort of wins, it'd be a much more impactful thing. So that my perspective was, I'm going to try and do this on a bigger scale and try and make it work for, tens of millions of people rather than a few thousand people that might have used Inferno. And I kind of handed everything over to the team. And there were a couple of engineers on that team who still maintain it today. I actually met up with the guy that leads the project now, and he came over to London, I think a few years ago. So that was really awesome. So that team is the project's still healthy and it's still maintained. I believe it's still got funding as well from Open Collective or something. So that was maintained, but I needed personally to separate myself so I could put everything into working in my new role.
How like between Inferno first being released and you leaving Inferno, how long was that? Was it like 6 months, a year?
Inferno 1.0 came out in January, just before I joined, or about the time I joined Facebook, and that was it. That was like the departure. I think by that point it had close to 12,000 stars in GitHub or something.
Yeah.
So probably about 6 months. Yeah, that was. I mean, the project I've been working on it for like a year, probably more than that. But I just didn't open source it because of imposter syndrome. I was like, no one's going to like this. People just don't want this library, And so that was kind of that's where that went.
Okay. Yeah. Okay. Yeah. Just for perspective. Yeah. Because it is definitely hard for. I've seen projects that when their initial creator moves on, it definitely changes their trajectory a little bit. But that's why I was trying to gauge how long it had been but it also probably affects your attachment to it as well. It sounds like you're ready for bigger things and okay, not rewriting React. You're going to build the next compiler. So take me through that.
Just to step back, my perspective is I just want to see the web succeed as a whole. I don't particularly have fanboyness towards things. I see a lot of what people go into these camps and they're so negative towards a competitive framework. I see that's kind of childish in some respects because everyone's all trying to do the same thing. They're trying to make the web better. They're trying to innovate, and people are trying to learn from innovation and do better. But the ultimate goal is to make your UI and your users who use your website the best possible, and the people that develop your website and make the website the best possible thing. So it's all in the virtual trying to do that. And the longest time I was also met up Rich Harris in we'd go out for drinks in London and that sort of thing every time he was around. And I remember poking him. This is way before even I kind of started Inferno, and hey, I've got an idea, and we'd throw things around, and he was working on Reactive, and that kind of inspired me to look into doing the framework, I guess, as well. So I was like, oh, I've got this framework, but I'm not going to open source it because it's silly. He was like, what is it like? And I was like, oh, it's like React, but it's way faster. And I showed him a benchmark, and he was like, whoa, you should definitely share that, So yeah, and then like you were saying, when I worked in a React team, we did a whole bunch of things. I did a talk on benchmarking React and seeing what the things were there. But ultimately, I saw the next big thing is a compiler. If you were to build a sufficiently advanced compiler, could it take your React application and compile it ahead of time and remove stuff that isn't needed? So basically fix the user's code, and make it faster. So there was a project at Facebook already started called Prepack. Prepack was a sort of ahead of time compiler that was built around React Native. It's making React Native starter time faster. And there were a bunch of folks based in Seattle who were working on that project. A couple of the guys working on that project had really esteemed backgrounds, working previously at Microsoft and working sort of a lot of theory around compilation. Very, decades worth of experience of how compilers work. And I'd never built a compiler before. I'd worked on this Babel plugin, and I thought, oh, how hard can it be, a compiler? And yeah, it's hard. It's hard. But it was great because going through that project and just teaching a compiler about everything. So what Prepack did was it followed the spec. It would interpret every line ahead of time and run it basically as if you're running it like normally as a JavaScript VM. But it would know the things that are abstract, in other words, things that it doesn't know, and it would know things that are partially known, and it would know things that are leak. That's where they go out to somewhere and you don't know about them anymore. So have all this compiler theory, around loops, around sort of aliasing, and it would generate a serialized tree and then output the content. So I hooked in sort of like the notion of rendering, that sort of the characteristics of React. So React had obviously classes, and you had a .render method, and that would process. So we'd abstract that AST and evaluate it. We'd see the render, we'd see the component you link to, and then we'd go into that component and extract that tree and the props. So we do all the things that the reconciler would do at runtime, but ahead of time. And then we put it all together. And what it amazingly did was it took the entire Facebook sort of comment reaction user interface that's on your news feed. You have all these like components, and it inlined all of them into like a 250,000 line file, a single component. That was the entire UI.
Right. Okay. So just because that's a lot, and I'm trying to like get my head around it here. What it tried to do, as you mentioned, is inline things in places so that you wouldn't have all these I'm just trying basically you want to keep the static stuff static. So what I mean by static is things that couldn't dynamically change. You would try and pre-evaluate them at compile time instead of at runtime. So if there was I know this is an example, if there's some kind of math equation that had one actual variable and then a bunch of actual constants, you could combine all those together. You could basically execute any. It was almost like flattening out the whole executions. So if you had functions that were calling other functions, if there wasn't something specific about those, you could inline them and then inline those, and then basically just I don't know. I'm trying to understand what you were explaining there. That was my.
It would even run things that it didn't know anything about. If you had fully everything abstract in a loop, could it unroll that loop?
Right.
At a fixed point. So there were lots of
loop unrolling. Okay.
So there were lots of very complex things. So even like object assign, it would be able to object assign things it didn't even know about, combined with some things, and actually give you the right output at the end. So it was very smart in how it worked. I believe the Prepack website's still around, so you can actually try it out.
That's funny. I'm going to drop a link in there for people to take a look at if I can find it.
So it could do state, it could do props, it could do context, it could do a lot of things. We taught it a lot of React idioms, and so it would do that. So it fully compiled and ran the test and passed the test it ran the same output for that test for the entire sort of bunch of components for rendering it once. Basically, it passed and it worked. But the issue was then you just had a huge file that was terribly slow. You can't have a single function of 250,000 lines and it not be slow, even though that was what was happening before. So that it proved that it was possible, and it proved that you could do this with JSX or with React Create Element. That wasn't the limiting factor, because at that point in time, there was this sort of faction where we use templates in our framework because that's the only way you can statically determine things, and that was just fundamentally wrong. You could do things with everything in React and JS and that sort of thing. And even today, this is basically what React Forget's doing now on a much higher level. So it's showing what's possible. But so that project was very interesting, even though it got cancelled. And it got cancelled because we weren't seeing enough wins. It spent maybe 18 months, and at this point we still wouldn't see any wins. We saw amazing accomplishments, but maybe fundamentally the biggest thing that came out of Prepack and the compiler was hooks. A lot of people don't know this, but that was probably the biggest thing that led to hooks, because one of the things that we found that was non-trivial to compiler was this keyword.
Right.
So in classes, you have this, and this can mean almost anything.
Yeah. JavaScript's great that way.
Yeah. So it could be bound to something else. It could be something entirely. It could be the global. Who knows? It could be anything. So from a compiler perspective, it was very difficult to understand what that was. So we kind of thought about making up an alternative API that would remove classes and go with functions and
Right.
enable the compiler to do more.
Then everything's in scope, right? Because like like a hook, you declare a variable, you see that where that variable is declared, and then you use it like you further down. Yeah.
So yeah, so it was. I even came up with the name hooks as well, which is kind of a fun fact. But yeah, the team worked hard and like iterating ideas and eventually came up with something that's kind of kept secret for a while. And we released it to the world at ReactConf 2016, 2017, no, 2018. Sorry,
18. Yeah, it was October 26th, 2018. Yeah.
So yeah, so the project got cancelled, but we did come up with hooks, and hooks was a good accomplishment. Although it wasn't perfect, and I admit that on reflection, there were some things about it that I would change, and that's led to some things here. But like, yeah, it was definitely a team effort, and it was a good effort as well. And we weren't too sure what would happen, like when releasing it, because we were excited, but would the rest of the world be happy about losing their class components? Well, not losing, but
It's funny. There's a comment here. Wait, so compiler therefore hooks, not the other way around. And the funny thing is, like, the number of times that I've heard this kind of story from the React team has been a lot, because there was that like 5 or so years where a lot of people outside of Facebook had no clue what React was working on, and then like after since the suspense talk, and then featured would feeling intentionally rolled out, but kind of realizing that they were. I realized like a couple years later that they were rolled out almost backwards. Like basically figured out what you wanted to do, then figured out how to like get there, like hooks, and then hooks end up coming out. But it was actually the compiler that led to hooks, not the other way around. It's wild. Anyway.
Yeah, and unfortunately, with such a project like React, you have a cadency to move slowly, not to cause churn.
Yeah.
Others, you have like an Angular 2 moment where like you have fragmentation. So we were very like cautious not to cause any fragmentation. And obviously, we wanted to make sure that it enabled things in the future. Because the idea was if you don't deprecate classes, you keep them around, but you come up with something much better, then organically people would go, well, I don't need to use them. This is fundamentally a better pattern. I'm going to go with that. So I think that's evident that it's happened that way, which has been good. So that's why you see React Forget being able to do the things it can today, is because like the prior work in the past has enabled that to happen. So so yeah, classes are hard for machines.
yeah. No, it's definitely very cool. So it's interesting. You said that you guys didn't see enough gains. Yeah, that's.
Well, it's the thing was we were in uncharted territory. There was no one else even attempting to do what we were doing, even like thinking about doing what we were doing, and so it was difficult, right? So there's always a very high chance it won't succeed in the way you think it will. But like I was always adamant that they could work. So after that project kind of like died off, in my spare time, I worked on my own compiler, and I archived it on GitHub. You can see it. It's called React Compiler.
That was the project you shared with me, because I remember you about 2 years ago or so, almost 3 years, you came on the Discord and you're like, you should really look at this, Ryan. Like, you should probably really, really look at this. And it was this compiler project that you did on your own time.
Yeah. So yeah, like all the things that people are doing today with Million and Blocked On, it was doing that like 30 years ago. Interesting though, it didn't clone templates, because back then it wasn't as efficient in the DOM to clone templates. The reason cloning the templates has become fast is because of web components.
Right. Lit. Yeah. And like, yeah.
Yeah, it was nowhere near as fast back then. It was actually much quicker just to create the elements individually or use inner HTML. So what back then I looked into was using bytecode. And it wasn't like binary bytecode. It was storing an array of integers and numbers and strings that would represent like statically all the stuff in your UI. Like this is a div, this is a span, and the codes would inference like this has a class, this doesn't have a class, and you can do this very quickly. So that was really fast and efficient, and you can still go there and check the code. So the idea was it would do that, and you'd get back your component, which would like be, use state, and then return JSX. the JSX would all go, it would return an array of all the holes. So the holes would reference the parts of your template that are dynamic. So for example, it would say like foo123, where foo would reference maybe the text content of a div, and then 123 might be some class. So the template outside the bytecodes would say at 0.0 of that array, that is my text number, my text content, and at 0.1, that would be my class name. So it would hook it all up. And essentially, and I've always been saying this forever, like there hasn't been many frameworks that aren't virtual DOM over the years. Like Svelte, in my opinion, has been virtual DOM the whole time. Interesting.
Yes.
That's my take. Anyway, it wasn't virtual DOM in terms of like you create a virtual DOM every time, but the virtual DOM has never really ever been about that. It's creating an intermediate structure where you're referencing parts that have values referenced back and forth, and that's exactly what Svelte 1, 3, and 4, probably 2 were doing as well.
Yeah. That's a fun way of putting it. That's a fun way of putting it, because I've always tried to point out, while Svelte isn't a virtual DOM, it's more similar to something like React than you'd think it would. It would be.
It's top-down rendering, where you have holes that represent values, which is what every single virtual DOM had in common, and non-virtual DOM frameworks had as well. I mean, it didn't have as much overhead. That's so there's differing levels of virtual DOM in my opinion. There's full-fledged virtual DOM. There's like virtual DOM where you create an alternative virtual DOM, which is what React does. Virtual DOM, like React today, is basically like 2 virtual DOMs. You have the one you create from your JSX and the one you create for your internal structure. And then there's differing takes on that. But if you were to go to the most minimal MVP of that, it would be there is no structure you create every time to represent your DOM nodes. You just create the values that represent your holes. And that's what Million and Block DOM and others do.
Exactly, yeah. That's the thing. You describing it was exactly like I had Aiden from Million come on the stream about 3 months ago. And yeah, this is very similar, like idea, almost identical. Yeah,
so that was kind of pretty cool.
I shared the link in chat so people can check it out. Here's the React compiler project. As you can see, this project was like 5 years ago. And around this time when you kind of put the seal on it 3 years ago, that's when you shared it with me and you came in the Discord and you're like, you should definitely check this out. This is.
Yeah. No, so, and I kind of pivoted this to the React team. I was like, hey, why don't we just like maybe don't do concurrent rendering and do this instead? And they were like, well, that's a huge change, I was like, okay, that was worth trying to ask, But I think also the fundamental point was that this was to show how far you could get with the virtual DOM. And what was interesting is signals in today's world were nowhere near as efficient then.
No.
This bytecode implementation was dramatically faster than Svelte 5 and everything we've come up today. And what's interesting is the reason why signals have improved so much in performance is inherently because of virtual DOM. So VMs over the years have seen the rise of React and virtual DOMs, and they've had to change their strategy in ways to deal with lots of intermediate objects, lots of intermediate monomorphic objects. And in doing so, they've inherently made it so signals, which you create lots of, and lots of closures, are now much more efficient. Yeah. Because hooks inspired having lots of closures within a render.
Yeah, it's funny how that works. I thank hooks for so many things, but the ironic part about it from my perspective, and I mean, you take it here or there, is like hooks, in my opinion, may have not been the best compositional unit. I mean, people have different perspectives. That's just my perspective. When I saw them, I immediately thought of signals, and I preferred signals. But because of the popularity of hooks and like the impact they've actually made the world better for signals, which is just wild.
And I think that was kind of a good realization for me. Was when I left the React team, I didn't leave the React team for any badness, or I didn't get kicked out or anything. As people, I mentioned it, I tweeted it like maybe a year ago now. There's an assumption that I left because I wasn't good enough, or I left because I wanted to like have normality. The issue at the time with the React team was it was always based in California, PST. So that's 8-hour difference for me. And 8 hours working in the UK meant that I was working like insane hours to make impact. It's a hard company to do well at. So I didn't have a great work-life balance from that. And I think also I'm like a workaholic from nature. So like it was a bad recipe. So I wanted a team where I could actually work my own hours. So I ended up joining a UK-based team that were
Gotcha.
building Workplace. And Workplace was like Facebook for companies. That's
Gotcha. Do you know what's funny? You just said good enough for that. I don't think anyone thought that, at least from my circles, on the performance side, because I've seen what you've done and seen the hard work you've put in over the years. I think a lot of people thought it was because you came in thinking you could speed up React using the techniques from Inferno, and then since they had their own ideas, that didn't jive. I think that was the perspective that I thought initially, but it seems, I'm glad you put it out there. Like, it's a little bit more nuanced than that.
yeah. In fact, before I left, I rewrote the React event system. Basically, we wrote it to be linear, to be far smaller, and also account for the sort of new way of how React 17, 18 would handle events. They weren't on the document, so it doesn't do delegation via the document, but via the root. And at the same time, I rewrote the synthetic event system and made it smaller and faster. So that was the last big thing I did, and then Dan Abramov took over from that and finished it off. But I said this for 3 years, and we kind of hacked on loads of cool things along the time. It was fine. There was no issues. I just needed my own personal life balance back.
Yeah, I didn't know that the React 17 event thing was what you had been working on. That's interesting, because I mean, I could probably ask you like at any time, and I don't have to kill people's time on the stream. But I was really interested how with the roots you guys got portals still to work. I've been meaning to look into that, but that's fine. I can ask you later. Okay, so now you're on a UK team, better work-life balance, marketplace. You're saying
Workplace, sorry,
yeah, workplace, yeah.
So that was interesting because I got to work on another infra team, but I kind of my mind kind of like I always find interesting problems and like kind of like so. One of the interesting problems, well, two of them, and also whilst working in the React team, I rewrote the sort of accessibility APIs that were never released in React, but they were like core fundamental APIs around scopes that kind of like, they power all of Facebook's tech for accessibility, and accessibility was always a very important thing for me, kind of push a lot and innovate a lot at the company. And then I continued to do that when I was in Workplace, but whilst doing that, I noticed that people in Korea couldn't properly type into the text fields on Facebook. It wouldn't work. Like that. And we use a text editor called Draft.js. And so we're going through and debugging dozens of issues. And it was a nightmare working with Draft.js and figuring out how it worked. But ultimately, it failed because it rendered with React. And that was the issue, because it meant that React was like the owner of the DOM. That was problematic in the content editable, because if you're the owner of the DOM, the content editable isn't a good candidate for the DOM. It tries to change the DOM under the hood, you know. And if that happens and React doesn't know about the change, then you get like remove child errors exceptions at runtime. So I was like, okay, this is clearly solvable. We can make a much better text editor. So I spent maybe 2 weeks making a prototype by myself, kind of hacking it, trying to get buy-in on a team that really didn't build text editors or do anything about that, and kind of like pivoted to the company. I was like, hey, let's go all in and make a new text editor. And they were like, what? But then I showed the benchmarks. It was like dramatically faster, like 70, 80% faster, like 80% smaller, amazingly better in accessibility. And it was called, at the time, Outline, which eventually became Lexical. And they were like, okay, cool, this is awesome. And kind of I had a fight to make a team and get a team around it. And it was successful. We had a team, rolled it out. And then it probably in a year became the most used text editor in the world, which is pretty cool. Like, it powers WhatsApp, it powers Facebook, it powers Instagram and Threads and everything, you name it. And then all these other companies kind of came over and like, hey, this is awesome, let's work with us and listen to. And so like, yeah, it very quickly after open sourcing it became a big deal. And that was really cool to see, like seeing like that, another thing take off. And also, what was the interesting thing was I really wanted to change the sort of mindset of how you work with text editors. Because at the time, there were only like 3 predominantly great text editors around, in my opinion. Preamble being one of them. It was a very good editor, but it had a really steep learning curve, and the API was cumbersome. People often struggled with that. Plus, it was huge in size as well. That was one thing we wanted to tackle, and it had good performance, but it wasn't great for the use cases we wanted at Facebook. The other one was obviously Slate, but that was kind of buggy for us. We couldn't get it working properly. And there's Quill, and so Quill was another one, but again, it wasn't maintained at the time, and it had a bunch of performance issues and code size issues. So it was a good opportunity in the space, unlike the framework space, which was very convoluted, like very competitive. I kind of overnight came up with an editor, and it kind of just got accepted as being like, we should try it. Why not? And it kind of took off. But that journey kind of got me back into open source from a different angle, and it also taught me a lot about the DOM APIs, because like we talk about like performance of web and like data fetching and suspense and like side rendering and hydration. These are simple problems. Wait till you do content editable and the DOM event APIs and try and work with the fact that Android uses like input events and composition events and dealing with WYSIWYG editors or WYSIWYG tools like Grammarly that change things under the hood, or using IME where you type in like Korean or Japanese, and that mindset of problems it grows. It's terrible. Like, yeah, like that kind of was like, wow, I can't wait to get back to doing frameworks again.
Yeah, I was honestly I wasn't sure if you were gonna come back. It felt like when we chatted during those Lexical days. Obviously, you're very stoked. I can tell you like whenever you're got your eyes set on a project, you're all into it. We've established that through the course of this narrative. But I remember talking to you back then, like 2020 and you being or 2021 and being like, trying to like gauge where your interest was on JS frameworks, and you're kind of a bit like, it's a solved problem, like. Like the performance, nothing's really changed since Inferno, and I tended to agree with you on that. But you're back, aren't you?
I'm back. Yeah. After Lexical, I decided I needed a new challenge, and then decided I wanted to build a framework. So I kind of hacked on this thing called Octane in my spare time, which was like React revisited, fully compiler, fully signal driven.
Yeah, absolutely. I was gonna say, how many React compilers have you written at this point? Like React, like.
I don't know, that's probably not true. I mean, when I get itch, I have to like kind of try it out. And I think I saw a stream of yours when I was like, I'm gonna try that. Like I've got some time now. I'm gonna try it out.
Right. Were we talking about like making a reactive language compiler? Like, was it back then? Yeah, like this the what I call it, solid script. I was just joking around, but yeah.
So I decided to build it.
Yeah.
And but along the way, what I wanted to do was kind of like sort of evangelize that into like, could a company enable me to take that idea and run with it? And the answer was no, but also in a good way, because I also rediscovered that I don't really want to be the head or author of a framework, because the negativity that comes with it is overwhelming. When I was in a React team, there were lots of positive, but there was some negative, and there are some people out there just not nice, and it caused a lot of stress, and like having like death threats and like messages from people over things you do was never nice. When I left Inferno, I got death threats from that, because people were like, "Oh, I can't believe you would abandon the project," And it's the negativity that happens in open source, unfortunately. So yeah, I kind of went off and I spoke to some folks at Vercel, one of them being Rich Harris and obviously Gramo, and was like, "Hey, could we do this?" And they're like, "Yeah, let's make this work with Svelte," and that's what it became. In fact, the repository was called Svelte Octane. I was like, the code name was Svelte 5. So yeah, like that's kind of where we've been up to. We've been hacking on Svelte 5. It's bringing those ideas of a new compiler from scratch, a new runtime from scratch, and going through and making all the existing tests from Svelte 4 and 3, passing Svelte 5.
Yeah, definitely. I mean, we all saw this announcement, the introducing ruins. Did I say it right? Ruins. People get on me because I always say like ruins, and it's supposed to be runes, but like it doesn't. I've said it wrong like my whole life, so I'm finding it challenging. But anyways, I quite enjoyed this blog post. I actually told Rich when I saw him in person a couple weeks ago, because it's got just the right amount of like tying in Svelte to the past, Svelte to the future, and then a few nice little jabs. I mean, we're going to talk about this in a minute, but I just want to ask you about like this one statement. Like every other framework, we've come to the realization that Knockout was right all along. You used Knockout back in 2013, 14.
Yeah.
Do you have any comment on this?
That was more of a poke. I mean, the realism was that Knockout had big problems even back then. It wasn't. There was, I guess, two parts to Knockout. There was the KO observable part, and there was also the template part. And so, if you took Knockout as a package, it was a mixed bag. Like the templating was a nightmare. The amount of bugs in it and issues that would happen in IE was, yeah, got nightmares over that. But there was a lot of good as well when it came to the observable side, or the signal side, as we call it today. And I think, although it wasn't completely right, I think there's a lot of things in it that it did right that we're now revisiting. And like I said, it's also a collective. It's like VMs have improved over time to account for these things. The mindset of the community is no longer like, I'm happy with okay, that's fine, you know. And also there's much more appetite, maybe because of Solid, maybe because of Vue, maybe because of Svelte, that people want to try these new things. And so like I think this is a good opportunity now to like take these ideas and bring them together. And that's also why I'm working on this effort to try and standardize signals, and hopefully that becomes a thing in the future. But like I do feel that there is a missing primitive that we should all have and use and leverage, including React actually, that would make this better. But it's missing, and it's something that we definitely want there to be, and hopefully we can standardize it so we all use the common signal pattern, and that will make interoperability, which is something that you don't even have today between frameworks, a great thing. Because it's fine to have a bit of Solid in your website and maybe a bit of Svelte and maybe a bit of Lit, because actually big companies need that.
They do.
Don't ask a company that's got millions of lines of code to convert it all to a new framework overnight, but they might be able to take a leaf of it and use Solid, or they might be able to take a leaf of it and use Svelte. So by doing so and having interoperability, that enables that to become a thing. I think that's important.
Yeah, no, definitely. And the biggest thing for me that I love seeing about this, right, is because as you know, when I came out, you know, with a lot of stuff with Solid, people were hiding the reactivity. I mean, we're still kind of hiding. We'll talk about that in a minute. But people were really hiding like the wrappers. Everyone wanted to pretend like their stuff was plain objects or plain JavaScript. Like that was like the goal at that time period. I spent a lot of time trying to convince people that we needed language around it. We needed to like that there was these three language features, and I'd write these articles where it could be like this is the signal, there's the state, this is the derived value, and this is the effect. And we are really seeing this the case. Obviously, with React hooks, even though when I talked to Dan, I realized they didn't really quite think of them in the same way. It didn't seem like when he was explaining, at least the derived values, they have a different perception on. But like for most people, very simply squinting, you know, at this, I mean, this is props instead of view state or instead of state here, but you can see the three pieces of the language very much on display, and it's really awesome to see those three language pieces basically being everywhere at this point, right? Like almost.
I mean, it's a shame we don't have something called like variable decorators, where you could do like at state or at derived before like the const or let.
Right.
Not this is not even an understatement. We went through about 50 different designs and proposals before we came up with this. We tried every single thing you can potentially think of before we came up with this, and we even went full out trying to use let, and const would be computed, for example. So there was no like magical rules, but that fell apart because in your idiomatic JS or TS file, you could just have let there. It could be in a loop. And then we're like, okay, well, maybe we like make it so if it's in a loop, then we don't. But then you can let outside the loop and pass it through. And so like, as soon as you start applying it to real world applications, it falls down. And then people are like, maybe we can have it work in Svelte modules, but not in other modules. But then you're like, well, you can't copy it out and paste it somewhere else. So it falls apart. You know, there's a really important part of coding that Svelte doesn't really have today that other frameworks do, and it's called co-location. The ability you can copy a chunk of code, paste it somewhere else, and it just works.
There was a comment that was like, "Oh God, please no decorators." But I was trying to say is like, what if you could just do like, I'm going to use Svelte's choice of state, or or you can even do it on the same line. Where does it sit, after the var or before the var, like this?
Well,
Or let, yeah, sorry, why did I choose var? Yeah. Like, what if you could do this? Like, this is very attractive. The trade-off here that I always like had in my head was the challenge is, if you do this, like say console.log this, I mean, there's no problem here. You obviously get 0, right? If you call it as a function here, you're passing function of 0, right? What's the other case? If you go count equals count plus 1 or count plus plus, this actually works because from a language perspective, we can actually see that this is a value access. So you get the value, and we can actually see that this is actually a setter. Like from a language standpoint, this reassignment can still work. The only thing that's interesting is, if you notice here, this function is 0 inside of function. So if you have function here and you got your value, this here, this value is not reactive, because you can't. Reactivity only lives within the scope of the declaration. Only reason I'm mentioning this is this behavior here of what a variable decorator would do, I think aligns with what Svelte's doing with its compiler. Am I correct, right?
Exactly right. In fact, we kind of hope maybe that this can help push that forward somewhat, because it really leans into, if signals become standardized potentially, then ergonomically you would like a short way of writing signals, hypothetically. And so then you could do something like this. And I think this is a more attractive proposition than potentially doing, function calls or having to import something or do create signal, because I don't necessarily see signals as being too important to expose to the user. Like, that's how things have been done up to this point, but you don't actually need that. You don't gain anything from having it. That's the weird thing.
No, not particularly. And I'm actually in complete agreement on that. That's actually why I released the article this morning, because I wanted to get that down in writing on my thinking on this, because the biggest concern, and now I'm going a little bit on a tangent here, but the biggest concern with the reactivity is implicit passing the mutability around, so you can no longer track like what's going on. The unidirectional flow, through stuff is kept, through props, through components, as long as the ability to set or update is very explicit. And with the scope-based approach, you see where that update happens. It has to be defined in the same scope as the thing that declared it. So there is a lot of value there. The biggest thing is that I didn't get to here is, like, if you ever want to transport this reactivity, you do end up wrapping it in a function, right? It's undeniable, because you need to be able to transport it. So I was mentioning how you couldn't get this count out here, but I'm not suggesting someone would do it in a simple case. But if you went this, you still can't write to it like this. I don't know why someone could do this, but if you went like this and then went called it as a function in here, now I got to change my example here. This could be actually reactive. So it's kind of subtle, kind of detail, but I do like the properties of the scope-based, in that the fact that it forces you to effectively write setters. Like, if your function wanted to update count, you have to be able to pass in a setter function into this thing, because otherwise there's no way, if you're just passing a value in or even passing a getter in, that it's possible for it to actually update something that only exists at the scope that it's declared at.
Yeah, I mean, we've had a lot of feedback that people would want something like a ref like you a wrapper, and maybe that's something we do. But the alternative is, rather than pass a function through, you pass an object with count, and rather than write get and set, we have a new rune that's maybe wrap or something, a dollar wrap, that you put around object literal, and the compiler will put the getters and setters in for you. And additionally, I mean, if you can kind of see this today, it's like we can do things that would help make performance better. So I tweeted about this already, but getter setters using closures, they're not quick. They're
No.
terrible. And there's actually, I'm trying to work with some folks to try and improve that. But separately, like we can just compile that away to make it super fast.
Yeah, no, that is an interesting point on that. It's yeah, I guess the thing that was attractive to me about this, on the other hand, is you said, maybe you can do some more compiler stuff to kind of make it automated and feel more natural, especially from the Svelte user standpoint. But on the other hand, just throwing it out here is, even with this, which I said, what I'm showing here hypothetically doesn't even use a compiler, but we can apply this to a Svelte compiler. You literally can still just wrap it in a function and it works, like without any special primitive or extra syntax or whatever. Like the fact, like you can just wrap it in a function, and now that function is reactive.
And that's exactly why we came out without those, because we wanted to test the waters and see if people would, after 2-3 days, people are angry. 5 days, they're like, oh, I tried out. In a couple of weeks, would they come across the same sort of intuition you have now? We're like, oh, it's not that big a deal. We can work this. That's what we wanted to see.
Right. This is why I was saying I think this scope-based reactive is a lot less portable. No, not really, in that you can just wrap it in a function. The funny thing is with Solid, and I said earlier I kind of agreed, is because Solid doesn't have an is signal. So I mean I do this on purpose. Technically, I know I probably should internalize an is signal. It could let me, like the renderer, do some kinds of optimizations that we don't do today. It's probably something that I might consider for the optimization standpoint. But I honestly, you as a consumer of these APIs, I don't want you to be thinking, is this thing a signal? I want you, like, as you mentioned, like, if you port this through, it's just a function. So like, if you have to like make is a signal a thing, you've kind of like it actually puts a bigger burden on you as the developer who's like creating your components. If you start like checking everything, if it's a signal, and treat it one way or the other, you almost just want people to treat stuff that they need to be reactive as reactive, and then the person who consumes it can choose whether they pass something like tie, bind, whatever term you want to call, something that actually changes to that thing, and then everyone's good. There's no like worrying about like what's a signal or not. You definitely shouldn't, like, we shouldn't be in this mentality of like, hopefully, of like, especially as I mentioned on the view side where you have these deep hierarchies, be worried about like signals as an API. That's my perspective anyway.
Yeah, I mean, and the other thing is like, potentially we can improve the syntax in the future, so we can have a thunk, like an arrow function without the need to have parentheses with nothing in them. Like there could be shorthand versions of them. And that would make it maybe a bit more palatable for people that are like, why can't I just do what React does and pass a value through from the return of a function, And that's, people say that, that's evident in like some of the feedback. And at the same time, one of the really great things about not having signals exposed is that we can change them and we can remove them as well. So in the future, we could find another pattern and we can go, well, we can change it. You don't need to worry about that. And that's kind of a magical power. That not having to expose them means that you can just change the entire implementation below someone's feet without them having any churn. So that's kind of what we were going for here.
Right. The reason I wanted to stop here a moment and talk about this was because when I first read this article about hiding it, I forget what example it was. There's something about reactivity being hidden. I kind of like was like, nah, like, and the reason was because of the function wrapper there, because I'm like, I can see that it's a function. I am still there, but like that isn't the important part, I don't think, right? It's not important that you pass the function or have that transport. It's that like within any scope here, that you're looking at, or here that you're looking at, you can see exactly what you want to happen, because you can see, look, I'm describing something where, okay, I mean, Svelte already had this characteristics because it's compiler, where, you can say, here is my count. This is, okay, so you're passing out the count that you get. Big deal, whatever. But here is the ability to update this account through this increment. So there is no other way this count is going to get changed anywhere in your app unless someone calls this increment function. You have complete control over the situation. Everything's locally scoped. Like, you have this power, so to speak, to think locally. So regardless of how you wrap stuff on the boundaries, who cares? Because you actually get to see everything. And if you move up a layer and then go up a layer, it's the same thing at every point. And I feel like actually that's what React and their model gave us. And the old like knockout days did not give us with their two-way binding and all that kind of stuff. It's like they didn't give us that ability to just like see what we need. This was always kind of interesting to me personally, at least. I don't know if you felt kind of similar. It's like when I saw Svelte, it bugged me that it wasn't composable, that I couldn't like build up these like custom behaviors, easily. Like, there's stores, but they're not like the same thing. You have to enter another system. But I loved that the abstraction kept all the principles of, unidirectional flow and whatnot.
Yeah, and I think that's my biggest gripe with signals over the years, was I love fundamentally what they were enabled, but I thought they were a terrible API. Because you end up with these weird things where you have maybe signal in libraries as a type, and you're like, really? Like,
Yeah.
That's as leaky as anything, right? Like, it could be a signal, could not be. I'll let both go through. And then you also have like weirdness around like setting a value. This is something I hated in Knockout, when you part the function, if you don't call it arguments, it's a get. You call it with arguments, it's now a set. It's like, what?
People ask me for that all the freaking time. They're like, why didn't you build solid that way? And I'm like, besides, well, see, the thing is that the argument those people make now is like TypeScript makes it more obvious what's going on. But like, I don't know.
Well, you have what you see now, and it's arguably better than all of them, because one of the things it gives you is it gives you much more clarity, even if it's slightly more verbose in some cases. But like I said, we can tackle that. We've not even released Svelte 5 yet.
Yeah.
So,
See, the reason that, as I said, we differ in our approaches a bit on how we like treat it. I mean, we'll see how far you guys go with the wrappers and stuff. But like, for me, when I take this create counter and I use it somewhere else, it looks like solid. So like, it accomplishes what I care about. So I think this is very cool. That's why I could see a world where like, if this actually got standardized, that's kind of cool too, right?
Yeah. I mean, right. I've seen that all the frameworks would actually adopt something like that. That's what would be interesting.
So, yeah. What do I want?
So I mean, there's many stakes here. There's not like just one thing we're after. We're not trying to just change like language and Svelte for the hell of it. We're trying to do things to improve things and make things more consistent, make things more scalable. We're not trying to copy some other frameworks. We never even looked at Vue 3's composition API. We're building this. We didn't even know about it. I didn't know about it.
Oh, this Ref Sugar, yeah.
I've never used Vue personally. So like, for me, it was like our goals were around our experiences working with the things that we worked with before. So for me, that's obviously working with Svelte, working with React, working with Solid, and obviously Inferno and Lexical. So when we were deriving these ideas, we were very much about, let's make things easy for the user. So when you have derived, you don't need to put an arrow function into it. You can just put it in an expression. And that helps as well, because it makes it feel more pure. It's harder to do side effects that way.
Right. Yeah. That is what I actually noted on the stream. I hadn't noticed that when I first saw the announcement. Then I was like, like little details like that. This is smart.
Yeah, and this is from my experience working with React. These are things that pushes people to the pit of success. The possibility of them making less errors and struggling less with their code, And so like we just wanted to ensure that, and that's been one of the caveats that, in my opinion, of working with sort of observables and signals in the past, that people just get tied too much up in the API with them and start trying to compose with them. They're like, oh, I do a get here, but then I derive the get, then spread it, then flatten, and then filter through it. And you're like, what? Did you really want to do that? Just use a for loop. That's probably easy, you know? And you come to code where somebody's gone over the top with all this logic, and you're like, I can't debug this. And so we wanted to make sure, because we're doing something different from hooks, because hooks can only be used with inside a component. You can have an event listener now that creates a derived and creates a state. You can't create an effect. That's one case. It won't let you do that. But you can do those, and you can compose and build up, like, you can proxy an object to make reactive arrays, and people have already done that. So you can actually have fully reactive, deeply nested arrays now.
Right.
For Svelte 5, even though it's not even available yet, and people can't really do it.
Yeah, I think I saw a project where someone actually took solid store mechanism and actually tried to build something like that on top of the ruins. It's pretty cool. That's
what we wanted. We wanted to endorse that sort of behavior, make sure that people can create really awesome things and share them. This is something that hasn't been a major selling point for Svelte in the past. There's been quite a lot of Svelte is typically batteries included. It's kind of interesting because many other ecosystems are very much we do the most minimal thing ever, and then you need to find your thing to do state and transition animations, and we're trying to do as much as we can so you don't need to do that, which is good in some respects, bad in other ways, because it can stifle innovation. Because then if you have something that does this already, do you want to use someone else's when it's already in the library?
Yeah, sorry. I was just remembering this. What I wanted to say about that earlier point is I think this is a logical place people get to anyways. If we're all working on basically the same constraints of the JavaScript runtime, and we're all kind of trapped by that and trying to accomplish the same things, I'm not very surprised that what the Vue proposal and the Svelte proposal actually ended up looking very similar to each other, to be fair. And when you were talking about earlier about using maybe a special syntax about pulling the stuff out across boundaries, so you didn't have to do the same get set and all that kind of stuff, I think they actually went deep down that path in their ref sugar stuff. They had dollar signs and then dollar signs and crazy stuff. I think ultimately, here it is. I think they ultimately ended up not going that direction. Actually, they dropped the whole proposal for their purposes. But I like that the difference Vue has is coming from a different place. I think for Svelte, this doesn't. It's a lot closer in some ways to what Svelte was doing before, but adding that extra capability. At least that's my impression.
Yeah, it's and the thing is, the typical ones are hey, I've got some dollar state and I want to export it from this module. How do I do that? So, for example, on that repository, if you press that add and make a a JS file on the left side, sorry.
Oh yeah.
So make this a something.js, whatever. So a typical request people have today is hey, I've got this and I want to do something I do with stores. So they go export const foo is state, and it won't work. It will complain. That compiler will say you can't export this,
right?
And then they'll come complain of how do I do this? Well,
so you're saying
it's an object, and the object is a way of boxing it up. So rather than have this framework notion of a box object like React does, and everyone does, I guess.
Yeah.
We're saying you can create a box yourself, but additionally, if you have all these exports and you probably want to export something else in foo here, you probably want to put in an object anyway, and then you can say foo bar, and then you can import those specific things, and they are reactive again. You just need to use getters, and potentially we can provide something like $wrap or whatever that might be, and then you can just access the values. You don't need to do .value, and so that's where we're going to, is that you can actually make a much better developer experience when you think about what you're actually trying to do rather than trying to just do what other people have done already and that just works. So we're taking the time, we're looking at how things work. And what's kind of interesting is if you go to something, actually, if you do it, if you take away the import for now, and let's do, maybe make a function, and inside there we'll do a getter setter. So we put count into it. It's create counter like before.
Okay, so just something like this.
Yeah.
All right.
and then we can move the count from below. We can put it inside.
Yeah.
And then we can return an object with a getter, which is count, I guess.
I just can't type. Yeah.
What's really cool is that's really slow in JS, like we said before. So if you look at the JS output of this, once you
yeah, I feel like if we don't use it, you guys are probably pretty smart. Yeah, we'll just forget about this for a moment. Okay. Yeah, don't worry about that output. Worry about this output.
So you can see if you scroll down. Oh, did we not turn it off? Maybe we turned it off. But yeah, we have some optimizations in place that can actually sort of improve some of the things. But yeah, so that'll be like state and then state.
And then yeah, exactly. Let's see if that changes it. It's probably because I'm not reading it properly. Did that change?
Maybe try to put a setter in it as well. Maybe there's some weird thing here.
Okay. Set v. Was it just a count equals v? And I'm missing a comma. Yeah.
Okay, maybe, but yeah, I can say what we've done is we've done some clever tricks there too. I wonder why that's not working. But yeah, and also like you probably saw is we try and improve. You need to put that in an array.
It's still a function callback. Yeah, sorry. Sometimes with Svelte, I just like because everything else is so short. I just state before initialization. What am I doing wrong? Create count, get state. That's fine. Use it in here.
Oh, you didn't put on the set. You didn't put count.
Oh.
Yeah, it's got the setter, but this is called set. You should have called it set.
Oh, damn it. Yeah, it's my bad.
I'm not sure that. Somebody will find that error.
Yeah, in the chat. Yeah, I'm counting on you all.
Maybe call it something other than state. Maybe call it like counter. It could be some bug in there. But it's still not really ready here. Like, yeah, there we go.
All right. What am I doing wrong? Return.
Oh, yeah, there you go.
Bam. Okay.
Check the best output of that, sorry.
Yeah. Yeah, that return is probably what was doing.
Oh, there you go.
Yeah.
Yeah, see? We detect that, we write your code so it's really fast. We're using a proto.
Yeah, so basically what you're saying is if you see someone, is it because it's a getter? You compile getters? Is that
we detect an object literal with the getters and setters and know to optimize them. So we can't really do this in JS files because this is not spec compliant.
Right.
It's not spec compliant because you may notice we do __ count, which would make a numerable property that previously wasn't numerable.
Yeah.
But if you were to spread that or something, then you'd have something you wouldn't notice. So
right. We do a similar optimization in JSX where we don't add extra wrappers and pass it straight through. But yeah, I got you. Yeah.
So that avoids using the getter closure altogether.
Yeah. Nice. I love little things like this because they all add up,
Yeah. And also, like you saw, event delegation as well as we hoist out events for you. You don't need to do anything about it. Right.
Yeah, this is interesting. Yeah, I was looking at this output the other day when I was trying to figure out what was going on. You guys have a behind the scenes walker, right? That's what these functions do. Like open starts an element, right, and then or
open will clone the element, and then specific
clone, right?
Sibling and child,
sibling, yeah, exactly, and then effect specifically for text. I love that. This actually one thing I love about the Svelte language is that when someone does something like this, just because of the way it works, I think that there's less possible things like that this can be text specifically.
Exactly, yeah. We also do some things which I think Solid should do as well. Is when you have multiple adjacent things,
text nodes, put them together.
Yeah, we put them together if we they don't contain a call expression, where a call expression might be something expensive or side effectful.
Right. Gotcha. Yeah.
So if you were to duplicate that clicks count that line and paste it below the one, you'll see what we do there.
Sorry.
So if you line 16, if you copy and paste it below.
Yeah. Oh, I see. Because now there's two of them.
Yeah. Oh yeah, we join them together as well. That's another thing we do. So we don't put individual text nodes. We join them and merge all text nodes into one. So if you put a span or something around each one, that will force it to be separate.
Okay. Yeah, that's fine. I mean, I can do that, but I'm sure I believe you. But yeah.
Yeah, they'll have scroll further down.
Yeah, get there. Yeah, so we got some childs, some siblings. Oh, okay. And then you have some render effect grouping here. Okay.
Yeah, but if you were to make counter.count a function call in one of those, it would break it back out again.
Interesting.
And so we treat things where you might do something expensive or side effect for potentially being a function. And we treat property access and just normal access as being safe. So there's our story. And that enables, otherwise you have the issue potentially of overfiring the shared render effect.
Yeah, I'm just trying to think here because that's interesting. Well, because doc count is just as likely to be a member access is just as likely to be a function as a function's likely to be a function, but
we in our documentation we're saying that if you do that and it's a getter setter, then it should be pure. It shouldn't be side effectful.
So you are pushing people more to property access over function call. Interesting.
Not necessarily. There's the difference in performance is tiny here, and we have last time I checked the most.
Yeah.
So, but I think from our perspective, just like Google Closure Compiler, that also treats property access as if it's doing something, it should be safe and pure. I think it's a nice sort of heuristic to have for a framework. But yeah, it's also because typically when people do something like Fibonacci would be a great example, you would typically put that into a function call rather than a property access. So.
Yeah, no, that's interesting. Yeah, because I never felt I could differentiate them, but that's interesting. Okay.
There you go. Maybe something you can steal back from us.
Probably not, because our primary primitive uses functions, right? Like Signal does. So because it's our default, I doubt we would change that, I think. Or could change that. It's interesting, though.
So we do a couple of other things as well. So one of the interesting things we do is we try and avoid doing it's harder to explain because you can't really see the source. But for example, when you scroll up there in the JS output, you'll see that we have further down we have $sibling $next, etc.
Yeah.
Those calls also handle hydration. So when it comes to hydration, we don't have a separate output for the code. It's the exact same client code that is used for hydration.
Yeah.
Additionally, what we do is we call the .next sibling call in a DOM node using its descriptor property rather than new .next sibling. So whilst profiling this, I noticed that we were seeing lots of deops doing .next sibling, .child. It was adding up.
Really?
Because inline, they weren't on the inline cache. So if you get the descriptor from the DOM node for that particular thing, and do descriptor.call given the DOM node, it's actually monomorphic. So
that's good. I've been debating on that piece for a while now, because the truth of the matter is this minifies slightly better, because you don't all these child calls get shrunk down to one character instead of next sibling next. Okay, so this is something I can steal back. I think that's pretty cool. Thanks.
Yeah, and so we do a couple of things like that to just where things about being profiling things that we notice. And another thing that we do in a core, as you notice, we use var. We don't change the user's code to use var. We leave it as it is. we when we generate a template, we use var rather than letting const.
Yeah.
It has a non-trivial effect on initialization as well, and that's because the TDZ or temporal dead zone checks that don't happen in var, and they're not cheap. They are actually a lot cheaper in WebKit Safari, but not in Chrome. There was actually a proposal for TC39 to remove them from Chrome, but that would be a break and change. And so the idea behind that is the check is to make sure you're not referencing a const value before defining the const value.
Right. Yeah. Like this.
So again, we use var, and var is actually a lot quicker.
I'm taking some notes. I'm just going to put that out. Yeah. So which ones do we have here? Use var.
Just go back to the replay on the recording. Yeah.
It's all good. Okay.
Yeah, so we do, unless we join strings together, which is a lot quicker than having a JSON text nosy update.
Yeah.
Another thing we do is we always ensure we never create text nodes directly, and we never use .text content. So you'll see here, we always have an empty space, and then we just update the node value. Not data. Node value is quicker than .data. So yeah, there's a couple of things we do.
Ooh, node value is quicker than .data. I got to add that. Yeah, we do the same thing where we create the space and we don't use text content. I did not realize that node value is measurably different, but that's cool to know as well. Yeah, these are great. It's been a while since I've actually spent the time to actually benchmark this stuff in great detail. I think it's been like 3 years actually since I actually spent a lot of time in the DOM stuff. It was back when pre 1.0, I was like sitting here going over stuff over and over, but I haven't touched it in quite some time. So these little tidbits are definitely nice.
Yeah, there's probably more, but there's hundreds of things we've done in small capacity to make things better and make things playable a lot nicer with other things. One of the things we're now looking into is, well, I'm kind of exploring experimentally is how we can improve hydration. So there's this whole topic around, islands and partial hydration and server components. We don't do any of that. We just hydrate from the root. And that works pretty well with Svelte because it's tiny, and now it's now going to get tinier. Just everyone who uses Svelte, you can now see your apps get even dramatically smaller.
Yeah, I think this is a big change. This is one of the reasons that I was so stoked about the approach this approach of using the same walks for rendering and hydration is same and solid, where you have like the template clone and then you basically just can walk over it in the same way. It means that like in old Svelte, I think Evan, you did that comparison with the to-do MVC app originally, and he showed that like old Svelte components scaled worse than a lot of other frameworks, but he also showed that with hydration, it was actually significant because it was sending down like almost double the code that it needed to because it's separate paths. Now, it's basically no size cost for hydration, I imagine, unless there's like a bit of runtime in like the core library that gets toggled on and off, whether you make a hydrate call. But on a per component basis, there's basically no size cost. So that's going to significantly improve stuff. Anyway, sorry, continue.
But we're investigating a two-phase compiler. So it's an optimizing compiler that runs not on your modules, but actually on the bundle, potentially. But also exploring if like maybe modules would generate a metadata file that would be adjacent to the JS file.
Yeah.
So the compiler would go through these metadata files or through the chunk or bundle, see where you hydrate something, and actually build out Prepack and the React compiler will go through your entire tree and actually like go, hey, I can see what props I'm sending this component, and I can just inline them. Or I can see that this component never gets re-rendered in the client ever, so I'm just going to remove any of the .child and .sibling and .open and .close and .render effect completely, including your .template. It all goes away because we know it can never happen on a client. And in fact, if you do this to like using compilers to the nth degree, then you can actually make something that's tremendously smaller, as small as anything from Quick or anything else.
Yeah, I mean, to be fair, Quick actually has a fairly large runtime. What you're describing sounds a lot like Marco 6, which we're going to have Micro Rawlings on stream next week to talk about. Just FYI, everyone.
I mean, Marco is actually ahead of its time in many ways, but just no one really uses it outside of, I guess, eBay. So, I mean, that's what we're taking these ideas into Svelte. These aren't necessarily new ideas, but it's more like applying to Svelte is quite a new concept. But these won't come anytime soon. There's actually a ton of things we're looking into how we can improve things. Like, can we improve how slots are handled and how you might do on directives, which are kind of like can you do something even more fundamentally crazy than that, make things a lot better? But that will come in like a 0.1, 0.2 release, likely.
Yeah.
We're not in Svelte 5. Again, error boundaries, another well-requested one. That'll be as well in a later release.
How about async? I know Svelte has the await component. I know that's an area that I've watched Svelte improve a lot over the last little while or last few time, because early days await component, I believe, would cause stuff to double fetch on both the client and the server. I think that's been addressed now. Have you guys been putting any thought into like async patterns in general in Svelte? Because to me, those are the two. Like, it's like error boundaries and suspense. It doesn't have to be suspense, but like whatever the equivalent, whatever Svelte thing is.
We don't have suspense. We have the await block, which is kind of similar in some respects. I think it would be quite interesting to explore that. We haven't, because we've been so busy with everything else.
Yeah.
But I think potentially in a later Svelte 5 release, we can do something there. I think we also want to see how things play out with async context, which is, I think, valuable to having asynchronicity between computers and signals.
Yeah.
It's quite complex to do that today. I know obviously Solid 2 is going to have some incarnation of that with the bubble reactivity layer, but I feel that you kind of still need to have an element of async context in order to make some things work properly.
Right. You're talking about the problem that all the runtime reactivities have around everything up to the await can be tracked, but anything after the await can't be. You're talking about that scenario? Yeah.
And not having tracking inside an asynchronous derived value, it works, but then it quickly falls apart. So that's why I believe we need that.
Interesting. Okay.
Maybe it plays out we don't need it, or maybe it plays out we don't. That's not required. But the thing is, like, this is like the next space I see people investing time into is how you make. We now have signals. How do you have a better developer experience working with asynchronous signals? And how does that even happen behind the scenes? Is there forking? Is there sort of like the mechanics of how fibers work, but it's on your sort of like signal graph? Or do you have something fundamentally different altogether?
Yeah, I mean, it's interesting. As you know, we did go down that path. We tried forking on a node level, trying to do something very similar to React's concurrent mode, but with signals. It's freaking complex and messy and imperfect, at least our implementation right now. I am definitely, double thinking that going into Solid 2.0, because I'm like, man, was that worth it? So yeah, there's lots of open questions there, definitely on our side as well. Yeah.
So yeah, there's a ton we still have to do. We have a sort of the next summit for Svelte is the 11th of the 11th, so not long from now. So in a couple of weeks we will have a summit where you'll find out some more information about Svelte 5. So
yeah,
anyone who's interested, check their data out. Make sure you check out the event, and we might have a few surprises for you there too.
Sorry, was that on November 11th you're saying? Yeah.
Yeah. 11,
Very
11.
cool. Perfect. Hey, if you got questions for Dominic, now is probably actually a good time to get rolling on them. Unless there's something else you wanted to show first, Dominic, but I know we're getting close to your time here.
Yeah, we're good.
Yeah,
minutes left.
Yeah, there's a couple things. I'm just scrolling back up in the chat so I can see some. I remember one of the earlier questions was all like, did you enjoy writing in Flow at Facebook? But I think that might have just been someone being cheeky. But did you do any Flow programming?
Yeah, I actually really enjoyed working with Flow. Not when I joined the company. Flow made massive improvements in my time there. In fact, I still find Flow better than TypeScript in many ways today.
Right.
It's definitely faster than TypeScript as well. They made a lot of improvements around its speed. I think what's more interesting is that because no one's really used Flow today, they don't really know what it's capable of, and like they're investing time into all different sorts of things. Like, it's got a new syntax, so you can actually use the component syntax, and it's actually open source. That no one ever obviously check it out. But like, yeah, you can completely do that sort of thing. It's
Right.
like, and that's what they use on Facebook, and it's like their own little world that uses this whole new sort of like type language. But I definitely see a future where we'll have types in the language.
Right.
I really do hope so anyway. Which leads on to that comment just now, JSDoc. Do I like JSDoc?
Yeah.
I don't love JSDoc. But I've got more used to it over the time. As you well know, we have a JSDoc framework. In fact, I started this compiler project. It was me that kicked it off to build Svelte 5, and from the beginning, before Rich and Simon kind of jumped on board. And I wrote it all in TypeScript, so we're going to actually go through the process of converting it back to JSDoc after.
Interesting. Yeah. I guess semi-related. People are wondering: are they're still going into the language tools? Do you know about basically TypeScript support in the markup in Svelte? Do you know if that's something?
Yeah, we want to add it to the template. There's a few issues. Like, here's a good one for people. We have an each block, where the each block is each item as item. Each item is as item.
Yeah.
And you can obviously see an issue right there. The as keyword is what we use and have been using before anyone thought of using TypeScript in it. But obviously that conflicts now. So we've been thinking, is there alternative ways? Can we have a full block instead of each block? Or do we change as be something else so that you can use TypeScript, So lots of unopened questions, like unanswered questions that we need to figure out in order to get there. But it's going to come. We have a lot of other things that we need to do first.
Okay. Yeah. No, that's the thing with these things. We just keep on. There's so many avenues that you can look. If there's enough people to work on frameworks, it's amazing what you can already do with the resources that you do have. It's actually cool. Is it the three of you now working on Evercell on Svelte, right?
Yeah, we're the three. We have the team's much larger than us.
Right.
And they've all been contributing heavily as well. But three of us full time working on this project. So yeah, it's been pretty full on, but it's been pretty cool as well.
That's awesome. The other guy, I know Rich is in East Coast time, and you're in London time, and who's the other guy again?
Simon is in European time. He's in Germany.
Oh, okay. So you guys are a little bit spread out, but I'm gathering not the same problems you had when you were working at Facebook.
East Coast is fine. In fact, East Coast is good because it allows me to get up and sort the kids out and do stuff in the morning. And
that's great to hear.
Then go into work, yeah. So.
I'm just trying to see if there's any other questions here. We talked about async, so I'm not going to worry about transitions. Just scrolling through chat here. How efficient are ruins? Will they prevent unnecessary DOM mutation? Yes, clearly. From what I can tell from this render output, this is, there's like detail differences, but this is a fine-grained reactive renderer with Svelte 5, right? It's very similar to what Solid does or what View Vapor is going to do. It's the idea of basically create the DOM nodes up front, walk them, add these reactive bindings or whatever you want to call them, and have them do fine-grained updates to the DOM.
It's as optimal as it can possibly be.
Yeah, exactly.
Maybe a tiny bit faster, but after you do those changes, and then you'll be catching up next week, no doubt.
Yeah, no, exactly. I'm glad to take it. As I said, it takes a lot of time. It's funny, like I'm sure you guys are going to do this like round, and you're going to like do a bunch of optimizations, and you're going to be sitting there working on the TypeScript thing and all the other issues you were just talking about, and it'll be like another 6 months to go back, and meanwhile the browsers have moved ahead and they've optimized something else. I've seen this back and forth a couple of times. I'm looking forward to take these learnings from Svelte in here. The last time around, Svelte improved its SSR rendering from some stuff that the Solid community had figured out in terms of getting the escaping code faster, and it improved in like the Marco's benchmark on the server, something like a 20 or 30% improvement on raw SSR rendering speeds in Svelte. So Yeah, no, we share a lot of ideas, especially now that like it's like the means or mechanisms here are really converging for the first time in a while. I guess like when the virtual DOM came out, everyone was kind of like, how do we do the virtual DOM in this? We're seeing like this is a different type of render. Earlier you were talking how older Svelte was almost like a virtual DOM. Would you
Yeah,
classify this as something, with Svelte 5 a little bit different?
yeah, I would. There is an element of virtual DOM even in Solid today, and that's what we call
Yeah,
it blocks. I think you call it owners. Is that where you have forks in the tree, conditionals, or each
yeah,
block,
the
you
control
also
flows.
have a temporal state that references the DOM nodes and the last state, the next state, and that involves diffing.
It does, yeah, yeah. The list reconciliation algorithm is like almost straight from Boris.
Yeah.
At one point, yeah.
So there is always an element of virtual DOM in all the things we do. It's just how much of that you want. And ironically, shared render effects are going back to virtual DOM.
Yes, yeah.
That's traditionally not something you do in signals. You want to have everything as an effect, but virtual DOM has proven that it's not as efficient as it can be because it's kind of like
Yeah.
yeah. So like I think what we'll be conversioning is a mix of all the ideas, the best ones from each, and we're saying these are what we want as our
Right. The power of fine grained, as I've been saying in the past, was that it just gives the control over it. It's not that saying that being the most granular is always the best choice. It just gives you the flexibility to have a control structure for this that isn't tied to the way the end user writes their components necessarily.
yeah. And in fact, one of the good things about runes is I see a lot of people say that runes are just sugar syntax for signals. Well, here's something for you. We can also compile them to not be signals.
Right.
If we see that there's no point of them being a signal, because signals are overhead at the end of the day,
Yep.
we can remove them. There was a really famous benchmark years ago called DBMon, DB Monster. And in fact, that's a really great use case where signals kind of fall apart. If the entire UI changes every single time, there is no point in like creating a whole signal graph, setting up connections for it to just then destroy the connections and rebuild them all over again.
Do you know how I solved that one? Because that one was on my list. But I use deep nested proxies, and here we go, diffing. So it was a virtual. Basically, if you use solid stores with a diff call on them, you basically go back to something very virtual DOM-ish. We got up to Inferno speeds, so like in the same ballpark. So yeah, but exactly, yeah. Like there are realms where like VDOM classically faster creation, signals faster at updates. This isn't like an all-in either side kind of situation, right?
Yeah. In fact, the quickest way of dealing with that would be two things. First of all, if you have signals that you'd understand after you inline the child components in each row and cell into the parent, you'd come up with a huge render block. And then you go, well, there's no point in having signals here, so you can remove them from it. So you end up with a single signal that is your entire render block.
Yeah.
And anytime it changes, you'd update that single render block, which will be like maybe, I don't know, I forget how many cells and stuff on that table, like maybe 200. So 200 node value changes every time. And that would be as quick as any vanilla JavaScript implementation out there.
Yeah.
So there is a way of getting both, and it's via compilation.
Okay. Can ruins be imported to just use its reactivity? Well, you need the compiler, right?
Yeah, you need a compiler, and you don't import runes. They're kind of like a magical, symbolic thing that's always there.
Yeah. So, yeah, the trick is, I don't know how to put it. There is like a signals library here, but you never actually touch it. Like you write the macros or the ruins, like the compiled thing, and then they handle importing those the internal details, the signals, so to speak.
Yeah, I mean, you can technically access them, but we have like svelte/internal, and that's obviously so we can gain access to them. But the issue that you'll find as a user is they don't have a very ergonomic API. There's no .get or anything like that. So you'll need to import the get function to use it on a signal and a .set function to use on a. So there's all these sorts of things you need to take into account. And also when you create effects, you'll then need to pass arguments, a bunch of Booleans and bitwise values. It will be, you won't enjoy it, but you could technically do it. And we have tests. Once we open the repository to the public and obviously show this, and you'll see the test and you'll see how it works. It's not something we're like trying to hide entirely, because I think it's very educational that people see this and go, oh, that's how you do it. But at the same time, most people shouldn't have to see it.
Right.
It can be a black box for the large majority of people out there, you know.
Another bump on this, thoughts on taking runes and making them generic and usable within other frameworks with different reactivity backends.
I think what we're trying to do is make signals themselves the thing that are generic and reusable, and then you get the best of both worlds. I don't think there's much use in getting the runes at the moment. I don't know.
Yeah, I mean, it's an interesting thing, right? If the signals themselves are browser spec and we all have the same like base thing, then in theory the ruins could compile maybe to something generic. It's interesting though, because even with the specs that we've been working on with the like for that group, there's still like a lot of like differences on how, you know, features based on different types of effects models. Like we're all pretty much, I think, in agreement about the signal state itself and like the derived stuff, but when it comes to effects, there's still a lot we're figuring out. So like it might be premature to try and make them all the same just yet.
Yeah, I think from my perspective, I want to definitely try and work with probably the solid community and yourself and Milo and others, and obviously the Svelte community, and seeing how far we can get with that implementation and make it so it fully works with both frameworks, and then seeing where the holes are, what we're missing, what we need to do.
Yeah.
And I think that will be the real test to see if this can be something that can be a proposal for TC39 and then can go from there.
Right, because yeah, for those who don't know, I've been talking about the signals spec effort kind of at a distance. I've been on the stream. Just in the last week or so, Dominic's been working on like a, what is it called, a prototype implementation, or is that the right term?
Yeah.
Reference implementation. Yeah.
An example implementation. Yeah.
Yeah. So it is progressing. We're hoping in a little while here we'll have something that, you know, stands up that we can show to other people, and then, you know, get more feedback and a wider audience. But it's happening. So that's super exciting, right?
Yeah.
Yeah. It's just so it's just so funny. There are a lot of comments that I'm actually trying to like get through and say them in a reasonable order. What do I got here? JS likes syntax in a JS file, but it's not JS. I won't work in non-Svelte code bases. I think it's. I'm sorry, you can answer it. I was just gonna say I think it's pretty clear that you're dealing with something like a macro. Like, if you use other frameworks, there are other compiler-based macros. You've seen dozens of different examples of them. So like, it's not so surprising, I guess. I don't know. What's your take on this?
First of all, it's completely valid JavaScript, so it won't break your parser and it won't break anything from that perspective. But obviously, you need to, just like you have already, if you use Svelte, you need to use a compiler. You can't not use a compiler with Svelte. But the difference, obviously, here is that we're now compiling JS and TS modules. It could be that we have a different prefix or file name, so it could be .svelte.js, .svelte.ts, and that could be the thing that we change to in order to make it more compatible or less conflicty with other things. So, like I said, we're still early. We haven't released this yet, and we don't fully know the answers for everything.
Yeah. I mean, this is the thing. You guys are taking feedback at this point, right?
Yeah.
So it's exactly like the community has turned around in terms of initial reception. I mean, I don't know what perception was. For me, I felt it was kind of split, and it's understandably split a little bit because on one hand, you have people liking the perceived simplicity of what Svelte, 3 and 4 does, versus the incredible more capability that comes with Svelte 5. I don't know. Do you have opinions?
This is something that I've experienced quite a lot from Lexical and hooks, is that when you release something to the public, you have usually about a week where everyone's like, I hate this. Why have you changed my beloved thing that I've already spent years doing? It's like survivorship bias, basically. When you're used to something and it works, and you have this perception that you shouldn't change it. That saying, if something works, don't break it or don't change it. But a lot of the time it's also because maybe that you haven't experienced the same issues that we're trying to solve, Like maybe we have, you know, seen a brighter side, and we can guide you to that sort of that place that we can kind of visualize. It's not always the case. People sometimes get it wrong, but we thought in this particular case that the response has been overwhelmingly positive, and that's like it was very positive to begin with, but there were obviously pockets of Svelte community folks who already, and it was mainly the Svelte community that had the sort of negative reception in some respects. I think largely it's been overcome now because they were able to play with it. We put a REPL there. People were able to explore things and try things out, and it actually isn't too bad. It would turn out, especially as you can see the output and you can see what you're getting in return, and you can still use all the same old syntax you had before. It will work. And there'll be some breaking changes because we can't make it 100% because that's impossible to do, changing architectures. But we've done our best, and we have a lot of tests that prove that we've done a great job there. So everything will still work. It'll be so much faster than before, and you'll get this new set of patterns that enable you to build apps more expressively, faster, with better dev tooling, and a whole bunch of more things in the future. It'll be awesome.
That's awesome. I know we're going to wrap up soon. There's a few questions I'm hoping I can just put in together at the same time, which is along the lines, do you have opinions and ideas about SvelteKit? Someone's like, does Svelte have something like Blitz? And I'm like, SvelteKit? Is SvelteKit something that you for you, are you looking at, like, I guess people are just curious about how that fits in. People are asking about streaming SSR, just like anything on that side.
So like I mentioned earlier about the optimizing phase, about hydration, that'll fit into SvelteKit.
Right.
We need to own the bundling there. So I think we have a ton of ideas for SvelteKit that will play in. Svelte 5 will probably come, the sort of alpha is our next goal, and hopefully we'll see that next month, next month's goal. And so people will be able to play with the code in alpha, try it out, but SvelteKit will probably come later. That's yeah. So exactly. That's something we want to do. So yeah, like it's gonna be good. I'm looking forward to it.
Yeah. No, I think I'm getting there pretty good on questions. Okay, fine. I got one more one. This is just because I'm being spicy a little bit here, because when I see stuff like this, here you go. I get asked this question like every day. So, is Svelte enterprise ready, and with new release, or the community still small?
It is enterprise ready. If I told you that sort of clients that use it, these are clients that are in, such as Apple, Meta, it's massive companies using it. I don't think we have an issue with enterprise, and it's obviously got a long-standing community. I think with every new release you have like this sort of like, do we wait for the release, or can we use Svelte now? I was like, you can use Svelte now. It will continue to work, just like anything that you try and use. Yeah. I don't think there's any fear that people need to have. The community is small compared to React, but then every community is small compared to React.
Right. And that can't be a reason not to try something. And the biggest one for me is that early days when these frameworks, Svelte, Solid, started showing up, people are like, oh, JavaScript frameworks come and go. It'll be like flash in the pan next week, this week, whatever. Svelte's been around for 7 years. Next month, Svelte celebrates its 7th year since Rich open sourced the repo. It was November 2016. And yeah, it's been, you know what I mean? Like, this is not a new framework. It's been used all over the place, but at large scales, at, maybe, stuff like New York Times and, like the COVID tracker, which is maybe a very specific usage, to, companies building, betting their startups on it, or, building, like, this is not like, oh, this is going away next week kind of thing. Yeah. How long, we were talking earlier about projects having, every 5 to 7 years, I think the web goes through like these cycles where you're like, okay, I need to update the project. And while I do that, I'm going to try and maybe look at framework tools. I'm going to bring all these things up. Svelte has existed now long enough to go through that whole span, and the truth of the matter is, like, when most people jumped on React, which got its numbers, in the first place, React was not around even nearly as long.
Yeah. I mean, I think an interesting thing you're seeing now is you're seeing spikes in lit that's coming up with like huge amounts of downloads, and it's people that are moving away from React.
Yeah.
Big companies are moving away. So there's already a change in the landscape. It's not like a massive change, but then the change from people moving from jQuery to the next thing was slow and steady. And still, jQuery is still like one of the most used libraries in the world still.
Right.
I don't know how many of those websites are WordPress sites that are like SEO holding pages, and that's a different story. But like, there's still a large amount of websites out there that fall into that category.
Yeah, and it's kind of interesting. I wonder that correlation a little bit, because web components are actually one of the best things about web components, on a side fact, because everyone knows I'm not like the biggest fan of web components, but like, is that they're actually really good for migrations, because they provide an interface between like layers. They're almost like a mini micro friend end, not quite, but like, I think that's when you see upticks in web components, sometimes it's actually for that reason of people trying to move from A to B. Anyway, just
I think that's why signals are important as a standardization process, because that will enable that to be easier. It's like the missing piece that we have, because I think you're always going to have differences in how you template things and how you declare things and how you write your code. But data flow, ironically, in JavaScript is always the same. You always use arrays or sets or maps, and you use something like RJS, RxJS, or you use something else. But they're just the same. The fundamental building parts is like they don't change,
Yeah, and the more we can adopt these, we have that potential. Like I'm sometimes critical of standard processes, because of like the speed that they can move at. But the truth of the matter is like the part of the reason why Svelte has been very successful is getting closer to the DOM, getting rid of some of these layers. Makes things like easier to kind of interact with. I think I saw an article, and this one talks about, well, Svelte allows you to easily interact with JS, so virtually the whole JS ecosystem is the Svelte ecosystem. This is true of Solid. This is true of actually this new things where when you lower that abstraction layer. I mean, to be fair, you can use refs and React and stuff, but it feels very different when you can, like, it's just the thing you're directing in. Actually, I mean, sorry, I'm talking about Solid for a second. One of my favorite things is the fact that a div is a div. Like, literally something, I'm not suggesting people do that, but they can go const div equals JSX div and like literally are holding the DOM in their hand. So as we find better ways to abstract the right stuff and lower the abstraction on the other stuff, like the capability widens there, and a lot of times the standards are what makes that possible.
Indeed, I 100% agree.
Okay, yeah, I think I'm good with Dom. This is not going to be the end of our stream. If you guys like, I think we've given enough questions, and he's got to go because his time zone is a lot later than ours. But this has been an amazing chat. I'm so happy to have had you on the stream and talk about all the things you've accomplished over the last several years. Is there anything you want to shout out, or before I let you go?
Thanks for having me. It's been a pleasure having this chat and answering these questions. Hopefully, we get to chat again sometime and catch up when Solid 2.0 comes out. I guess, if anyone else has any questions or is interested in any of this, you can follow me on Twitter and on GitHub, and and you can ping us more. I'm on Discord as well, so you can find me there on the Svelte channel. If you have any questions, ping me and I can hopefully answer them. Otherwise, thank you.
Yeah, no, thank you. And with that, we're going to say bye to Dom. Yeah. Wow, that was amazing. It's very cool to see that whole progression, and very cool to see what they've been working on Svelte. I obviously I love the back and forth there for a moment there, where Dominic's like, yeah, we saw what Solid was doing, but we also found these optimizations. I'm going to definitely be going and looking at a few of those. The frameworks now are actually incredibly similar. Someone asked earlier, are all the frameworks just the same with different syntax? Not 100% as you're seeing here, but honestly, Vue Vapor, Svelte 5, and Solid are very, very similar. And obviously, I'm pretty stoked to being a big part of that happening. And Dominic, obviously, has always been a big influence for me. So very cool to see. Yes, the CEO of Hooks. Yeah, it's funny. That's not Dominic's legacy. He's not going to be known as the CEO of Hooks. I am pretty sure. Even if he came up with a name, sometimes names just come to you like bling. I don't know. Brian, why do you decide to make props a prosecutor, not a proxy that returns getter functions? Sorry, I might be missing this. Props props don't generally use proxies unless there's a spread in them because the shape can change. Generally, we just use objects that are getters directly. We only use proxies when there's a spread. But why don't I make them a prop? Oh, I see what you're saying. Why don't props have come back as functions? Well, it's a little bit weird using JavaScript land in the sense of there's a couple reasons. Identifying like has like in like it's weird to like if you want to check the existence of a property, especially if the shape can change because of stuff like spreads. Making things function is like another thing. It means that like every time you access or potentially ask about a property that could be there, then you're actually having to create a function even if it's not there, right? Like how would you ask if something's there? I don't know. I think syntactically the approach we use is a lot cleaner from like a dealing with object standpoint. It's also nice from the perspective of like I mean, this is a subtle one, but when you keep that locality and mentality when you're passing values through, like whether it's a signal, whether it's a store, whether whatnot, you can keep the same interface when you use props the way they are instead of like interjecting functions in. I'm a pretty big fan, obviously, of the approach we've taken. It's not quite the same as Svelte's compiler where it's just like a variable, but it's as close as you can get without using using like compiling JS syntax. We only touch the JSX. We don't actually touch any other JS in any other file, even in your components right now. Do you think you should join the Cell Tune abandon solid? Hard to say. I mean, it's something to think about when you like build something and then everyone else seems to be doing the same thing now, a couple years later, or a few years later. So like, but I mean, the writing was on the wall, right? When in my opinion, when Adam Hale created Surplus back in 2016, or he created earlier than that, but when it showed up on the JS benchmark in 2016, it was obvious to me that this was going to be the future of frameworks. So like, I changed some stuff with Solid to get it, I said, more human usable, my ergonomic deal with design issues. I said like locality of thinking, but like, yeah, I don't know. It's something to consider, when people, basically end up all converging on the same spot. That's the thing is I've had a lot of time to think about this, right? Solid, like what Svelte 5 is just getting to now, what Vue Vapor is just getting to now, Solid's been like that for, 6-7 years. So we've had a lot of time to kind of progress our thinking there and take more lessons. Obviously, those lessons are being shared with the community, which is feeding also into Svelte and the new versions of Vue. But like, I got a lot more to do. And like, obviously we're going to have like little bits of difference of opinions here, right? Like, I see benefits in compilation optimization. I do see that, but it's also, I think there's a balance between, let's say, how much transparency you want to have, right? Like how much you want to keep the stuff in JavaScript land. Do you go to compilers early or not, right? How much do you lean on this stuff, right? Like, because something has function semantics, why not just make it a function, Like, we have differing opinions, and I think that's a good thing. Just catching up on chat now. We're going to do This Week in JavaScript. There's been some hot stuff around the builds stuff this week as well, and I want to talk about some insights I've learned about both server components and Solid 1.8. I think there should be just one implementation of Signal, which is Svelte. Solid seems to be done. Okay, that's funny. Let's move on. Like calling something redundant, like years after the fact is kind of funny. It's like, yeah, I don't even know. Yeah. Okay. Proxy. Yeah, there's a big syntax thing. I think Rich actually hit this on the head. Like a lot of people care about the syntax. Like that's what drives them, the familiarity of this stuff. And when I was like you could tell Dominic cares maybe about that, like myself, a little slightly less. We're more on the mechanical side, right? We see the best way of doing something. We just want to build that, right? And then, those other details, we're trying to like tie them in, but that's not the primary focus there. So it's like, I think on the user space, there's a lot of choices there. I mean, if people like want to be like make those narratives the other way, I mean, what can I possibly say beyond the fact that like we built something with Solid, as I said, 7 years ago, and now people seem to be doing the same kind of stuff. Does it make Solid redundant? Maybe. But then on the other hand, like, would we even be here? Yeah. What do you think will be their biggest challenge in building a React compiler? Do you want to know? Okay. I'm pretty good. Talk about this. And actually, let me share my screen for a second, because the biggest challenge is, I think the React guys want, let me see if I can go back, is an example here. They don't want to have this get and set here. Yeah, this is actually a prime example. They want you to be able to do this exact example without a get and set. So let's pretend that it's like something like this, return count, okay? They want you to be able to do this. And this could be in a separate file. So what's interesting is if you do this in a separate file, stick this over in something over here, let's export this out. I'm just going to use this, export create count. Okay, right? So create count. Okay. Now, as you guys know, this is not going to do anything or work properly because that's not how the Svelte stuff works. But they want to be able to do this more or less. And what's hard about this is, does this guy know that his value is reactive? Right? Like Svelte's using the fact that it's kind of leveraging these getter and setters, right, at a runtime factor. But now it looks like this and like this, essentially. Does this actually work? That's funny. Is there an implicit transformation here? Let's see. Why does this work? That's an interesting question. I wasn't expecting this to work offhand. But like the something that I'm not expecting is probably happening here that I'm not seeing. But the general problem is porting reactivity across boundaries is generally challenging. What is going on here? This is actually interesting. So it creates a source and then it wraps it in a get, which means that it shouldn't be settable. And then, sorry, I'm just looking at the output here to see if I can figure out what's going on. And then when we call create count, it's wrapping it as a source again. So Svelte's compiler is actually doing a little bit of something here. That's interesting. And then it's mutating it back in local state. That is interesting. But generally what I was trying to get at is erasing boundaries is the challenge I think with Forget might not even be a technical challenge. It might be actually the fact that like lacking the language, like if you go, there's a balance here. If you go too far on the language, compilation side of things, or like, sorry, if you try and make it just work as just JavaScript and you lack the language to express certain ideas, it's harder to actually see what's going on. So there's this careful balance between making it invisible versus it being there. Like Svelte having you pass out the functions of the getters is actually quite powerful way of actually telling you what's going on. If you take away everything, you kind of lose that a bit. But they have more specific challenges they're dealing with, because they want to be able to support stuff like I mean, I don't know why you would do this, but like I'm just making stuff up. Like they want, yeah, I don't even know how. Okay. They want to be able to support arbitrary mutations and like pushing to arrays and flow like inside the components, and have that traverse across file. There's a huge amount of analysis involved to make that stuff actually work. Anyways, let me catch up on chat. Svelte is not in run mode. No, this compiled output I think is. Oh, so interesting. So it like falls back to VDOM, like kind of like how Quick works. Interesting. That's interesting. Yeah, this is something that Quick does, where it like falls back to like that. That's interesting. A bunch of people in chat are like, I've never seen this. Oh, interesting. This is the thank you for the details here. This is very helpful. So it's basically has that fallback. Yeah, to keep backwards compatibility. That makes a lot of sense. Interesting. Yeah, I guess that's the only way to kind of bring this in gradually. That's tricky because it's quite a considerable deopt structurally, but it's interesting. Yeah, this is one of those things that I've had one of those things that like you can literally see what the Svelte code compiles to here, right? Like this is actually like more like when we had the older version with the, so I'll go back a bit. When we had like the older version where we were doing all this stuff, like Svelte is essentially compiling to this, which is what's like you could write this in solid and it would work, create signal and then count and then set count here. Like, there we go. Now it's, now this is solid. Create signal, count, set count, you know. The biggest difference is, and this is why, again, why we have different frameworks, right? Is this is completely runtime. To save yourself that typing, like you now are introducing a compiler that has to look over all your JavaScript code and all your JS files and then like make a decision of how to act differently. Like effectively you get the same result pretty much. And even the same properties of like, generally of like signals not being a thing. Like we don't have a maybe or is signal thing. Like we don't play that game. But like the thing is like, and I mentioned this on my previous stream. Look, get count. If I have a count variable, I don't wrap it in a getter. I just use the count variable. Like, why do I think to wrap this in a function? And it's because this is a function call. Like, even if I didn't write a function call, it's mentally a function call. So, in a sense, there is a graph that I'm seeing here. This saved me typing characters, but it did not save me any cognitive overhead. So. And for me personally, I think it adds cognitive overhead because now, like, I know that there's a behavior going on that isn't actually just JavaScript. It's like there's also a compiler going in and doing this. Whereas like for the cost of just putting a parentheses in, I don't have to think about what a compiler does. It just doesn't exist. So there's a trade-off. Some people prefer one way or the other way. So like, and as I said, the second you pull this out in Svelte, like, okay, you're doing dot value, but you could also make this a function call. You can just call dot get and dot set. Let's do this. Like, we're not particularly kidding ourselves, so to speak, right? Like, what is it? So counter dot set counter dot get +1. I mean, this is terrible, like very verbose syntax. It's like mob X is box syntax. But what I'm getting at is like, these are functions. Like when I'm like this really isn't a big deal. Like, I don't know, like compared to the extra mechanisms going on around, like this is about as trivial as things get. Okay. Yeah, I mean, you end up in exactly the same place once you do one level of abstraction. It's kind of, but like this is like a common thing. Like, can I give you another example? Svelte devs will probably represent this. It's actually too bad we didn't have DOM on stream when we went into this piece, but it's fine. Svelte has control flow. Like it has like if and each. But if you want to make a custom control flow, you have to monkey rig completely different syntax. That's fine. They have a native syntax for it, which is like a language feature, and then they have a composed syntax for it, right? So like if you want to pass variables into each, I mean, I can just go to the Svelte docs, I think, for this Svelte dev. We want something called what is it? Is in the tutorial? I can find it. I'm looking for what is it called? Not advanced Svelte. I'm looking for slot stuff. Where is it? Is there something about slots here? Reactivity, props. No, I'm looking for. No. Yeah. Name slots and slot props, I think, are the things I'm looking. I'm looking for slot props, I think. I've built this before in a whole stream. I just don't have it in front of me right now. But you end up using this much clunkier syntax to pass new variables. Like if you made your own for loop, you don't get to use each. You have to actually make a component that then uses like these, I think it's slot props or slot variable syntax, where you use like prefix attributes as a way to say like pass this into the context of this array and all this stuff. And my point is like, it's all we chose to use a for loop component because it's like literally the same thing you'd use as an end user. You have the exact same composition pattern. So like it's idempotent. Like if you create a signal in Solid and then you made your own signal, they would look identical. But in Svelte, you don't have that property. It's a property that I value. In Svelte, the native things look different than the composed or built things, right? You use hashtag each, or you use $state. But once you build something with it and you make your own abstractions, they don't act the same. Whereas in Solid, your primitives, my primitives are identical. Right. Right, because I know what's going on inside, of course, right? But and I think this is an important detail. I think this is why Svelte really works well for people kind of coming in, newer people, all that stuff. I built Solid not for other people. I built it for myself because I wanted a framework that could control all the details. Like I knew exactly what I could get out of it. So like I can never unsee what I see, and that's the situation, right? I think the beautiful thing here is developer experience, debuggability, dev tools. Now that we're all in Signals, we'll be able to make big advances in that. I don't think the syntax actually matters at all. And as I said, effectively, the second you do composition in Svelte, you're basically back at solid. So it's only like in that one little zone that is different. And I mean, some people could argue that compilation makes debugging harder because it rewrites your code. I don't think Svelte's compiler rewrites stuff in a way that makes it really any harder, especially with this mode. Older Svelte, a little bit trickier. That would have been a complaint about like Svelte 3 or 4, but Svelte 5 looks pretty sweet. With getter aesthetic proxies, compiler constructing is always a problem. We're just passing signal around because the access readout there basically calls a function. Yeah, I mean, this is basically the problem, right? You could add more compiler magic as wrap to try and like hide this fact, but the problem is there is a graph here, and as much as we pretend it's not there, we have to compensate with more wrappers which indicate to us it is there. So it's like you need to know about the problem to then solve it by using these extra wrappers, at which point like you're just doing a lot of extra work for like it almost completely flushes out for me. It's like if you can put a $sign on something instead of calling a function, for example. This is not the same case here exactly in terms of syntax. It's like it's doing the same thing, but now you aren't using native JavaScript. You're using a compiler, and you save, in this case, like one character. It's like, but it's like one thing over here, one thing over there. It's like it doesn't actually matter, but people will think it matters, which is like why I think there's like a certain aspect of that where people will care and like it. Yeah, I'm not quite sure I follow. Have you thought about modifying wrapping DOM methods of updating HTML with the fact that, I mean, that's what our JSX compiler does, right? You put a text content prop on an element and it goes create effect text content. It is text content. You mean like it's just like hook type APIs? I think there's a good argument for like, I think JSX is compact. I think seeing HTML is kind of proven its benefit. Yeah, the let direct phone props slots. Thank you. You guys, I'm catching up with the chat now. Sorry. Yeah, I mean, to be fair, these already exist. We've had them for years. It's a funny thing. He mentioned that Vue had that ref sugar thing that looks exactly like Ruins. Well, Solid has something called Solid Labels. Came out November 2021. You can use something that works just like Svelte Ruins in the Solid ecosystem. I think they had a new release this past week. So we've had this for 2 years, if that's what you care for. I just never push it because you can tell I don't believe in it. And that's good. That's why we have different frameworks. Yes. This is if we get standard signals, this is what we get. Picture if you could have like stack traces based on the reactive graph rather than the runtime. Like instead of having the queue, sometimes if you ever debug in a reactive graph, you'll sometimes like see like, okay, this change happens and it queues these things, and then later you'll see a queue run off, and then you get there. Picture if you could actually track through the dependencies and stuff, kind of like what MobX has a tool for that. It could be built right into the browser for everyone. That's like the kind of wins that I want out of the standardization. Yeah, the problem is VDOM does make a bunch of garbage nodes, but when you're doing optimal stuff like block DOM type approaches, or like a naive VDOM is going to be worse. But like the stuff that Dominic was working on, stuff Aiden with block DOM was working on, they can save a lot of that creation because honestly all they're doing is they're just getting a bunch of data and diffing it. When you create stuff for the and in the case of creation, you're just like basically getting the data and drawing it. When you create signals, you have this extra memory. It's almost like when you add memoization in React, where you get this extra memory for all these different primitives. That's why we group effects. That's why we try and, I don't like APIs that lead to people overwrapping. It's because we don't want this extra memory usage. So like, classically, back in the day, everyone made every binding a different effect and every component prop a different, like computed or memoized value for each prop, and they made every component had its own wrapper, and they made all these tons and tons, huge graph for components, and it made it very heavy. And this is the state of art. This is what people were doing, and it sucked for performance, Ember and stuff back in the day. And React came out and was like, look, VDOM is so much faster. And I was like, no, it shouldn't be. Like, obviously, fine-grained updates, updating one place in the DOM when you trigger something instead of re-rendering is way faster. But for creation, you're taking all this upfront memory overhead. So I was playing with it for a year and a half when I saw Surplus from Adam Hale, and he took the opposite approach. He tried to do the least amount of possible here in terms of that creation stuff. He was even grouping effects for elements. I took that further and added template cloning, but he was still doing a lot of the kind of base stuff that we did in Solid. And I saw that, and I was like, wow. It was almost the opposite extreme. I'm like, he's not doing enough. Components are like, you can't think locality. You're passing signals everywhere. Like it didn't learn enough from React, but he showed that it was possible to have a reactive library faster than like most VDOM implementations. So like but the way was he optimized reactivity for creation. And that's what I focus on a lot here. Updates are easy. VDOMs update probably fast enough, and signals update like way faster than they'll ever, like we could give up time on updates significantly given how much faster we are than a VDOM on updates. But creation, we have to work hard on. We have to keep our memory profile low. We have to reduce our overhead. So like this was a classic trade-off. This is why when, the signals stuff all went down back there, the React guys are like, oh, signals libraries are slow or whatever. We changed that. We looked at how to reduce that overhead. And now, partially because we leverage the fact that we render once and can optimize for that creation ahead of time with a compiler. So that's, our JSX compiler isn't that complicated, but on the, we're not like doing Svelte rewrites of your user code and stuff, but you still get that benefit of, if we can look at it with a compiler, then we can do some of that work ahead of time to optimize the path for creation. And if we do that, that's enough to make the difference. Oh yeah. I mean, that's a whole other thing. I mean, modifying the standards people are actually interested in this side note. There are people who would love if we get signals in the DOM to be able to, in the browser to be able to use the DOM APIs like this, which is, it's attractive. I think the problem is effects. I don't know how the scheduling effects is really iffy situation when you consider stuff like suspense off screen and whatnot. And I don't know if the DOM, like standardizing on that kind of stuff, is actually really tricky. Yeah. Okay, cool. Let's get this week in JavaScript going. I got lots of stuff to go on here. More of this conversation. I'm going to pop out on my screen here for a second so that I can get us ready. But yeah, no, thanks for asking the question. I love talking this stuff. I think it's really cool to see the interest in signals. I think it's really cool to see how like there is a lot of convergence of ideas, right? Let me see. I've got some bookmarks here as well. It's just, this area, in one way it's very old, but in another way it's getting more attention now than it's had in years, which means things are still moving fairly quickly. Sometimes I feel like my best input is based on just experience with using these patterns for so long, and with users, you know, having, feedback and going through these cycles. I can bring that experience to it, but there's a lot of really smart people, working on actually improving the algorithms, the performance, and, changing really how we look at this stuff. So yeah, I mean, in general, I'm very excited. Okay, where are we? Yeah, okay, that's where this starts, isn't it? Okay. Okay, sorry, I'm just getting myself all in the right place. Yeah. Okay, perfect. Yeah, I think I can start there. That's actually perfect. All right, how's everyone doing? You all still alive? You ready for This Week in JavaScript? Yeah, no, this stream's going to be a good one, I can tell when we go back. Okay, so let me flip over to that in 2 seconds. All right, where are we? All right, it's time to talk about This Week in JavaScript. For me, there's been a lot of discussion going on the last, little while with, the release of Svelte 5 Ruins, preview or whatever you want to call it. It's not officially alpha or beta but to be able to play with it, about the nature of signals. We've been seeing this stuff all over the place, but more people are now seeing the aspects of fine-grained rendering. And framework author, creator of OB, reactive library, and VOB framework, wanted to point out an interesting feature in Solid. And I mean, it depends what you want to call it, feature or bug. But this is something that we saw today in our Svelte stream as well, which is the idea of grouping render effects, right? What he showed was in Solid, if he went in here and put a random number inside one of our bindings and then updated some state that was unrelated to it, keep in mind, he's purposely using attributes. When we insert children, they actually happen independently, but he's using text content. No one actually uses text content like this except for optimization. So basically he's showing, like, if you update one attribute of an element and not another attribute, and there is a calculation that isn't in a memo, it will actually change random colors, right? And we saw that Svelte 5 actually does a similar grouping, again, because we have to optimize performance of creation over update, generally speaking. That's what makes this whole approach viable. And but the question is this expected or unexpected, right? And I could definitely see why this behavior would be unexpected, right? The poll was pretty split as well, right? It was definitely leaning towards bugs. The funny thing is, like, the funny thing is that, the text content is just the problem, right? But my point is, it's because it's the types of situations where, like, the text content also makes it more feel disconnected and obvious. So most people using this sort of example wouldn't have such an obvious case. Like, it is a bit scripted for the scenario. But I wanted to talk about this one because if you're using React, you're used to everything re-rendering. So, like, this would 100% happen. But if you're using Solid and you're like, it's fine-grained, this shouldn't happen, right? Like, these updates should happen all independently. Well, there's a cost to that. If you listen to Dominic, it can be an actually extreme cost to that. So, we always tell people, if you have something that's expensive, then, you should wrap it. But what if you have something indeterministic, like random, right? It's kind of the same thing. Obviously, this scenario, he wouldn't, like, as I said, it's staged for this, but it's right. It is pulling more than it needs to. And I want to actually pull up an old article that I wrote to talk about this, because we talked a bit about it with Dominic on stream, but let's see if I can find it. It's called performant form. Okay, it's that old. It's not even on my first page. Performant. I wrote it. Yeah. No. Where is it? Thinking granular. How is Solid.js so performant? I'm going to drop this one in the chat for people. So one of the important things that I think gets missed here is I want to say I have this whole section about because we think granular, right? This is where I laid out why this model is good, and it's why is it Vue and Svelte 5 are picking it up. But yeah, use a compiler to get the creation benefit. This is what I was talking about. Cloning. You want to clone the DOM node, optimize creation on memory, loosen the granularity. Number 3. What? Make it less granular. Where we are paying the highest cost on update? Nesting, doing unnecessary work, reconciling lists by far. Now, you might be asking why even reconcile lists at all, whatever. But the whole point here is that the biggest creation cost is creating all the extra computations. You can't do much about end user code, although I was looking at how to merge end user computeds and effects at one point. But generally speaking, I can see both sides of the argument. One side of the argument is that this is just incorrect because you should be all React or also like fine grained. There should be no middle ground. The other argument is that it, for the most part, doesn't matter, and we optimize for the common case in the hopes that if something weird does, not even weird, but hoping that if you in a situation where it something executes more often than you want to, it isn't that hard to optimize in the specific case, right? Basically, there's already so much of a win by reducing this overhead that in these kind of forced situations, then, so be it. Grouping effects. So we saw this also in the Svelte example earlier where he had 2 text updates like inside the same render effect. We do this so that we only create one effect. Technically speaking, if I move the text content into a span here, then it doesn't happen. What's happening is, okay, you know what? I have to show this for people to understand, I think. Let's do this. Let's trash can this. I'll see if I can make a very basic version of this example, show what I'm talking about. Okay, so he just added math random. Okay. So, sorry, let me see it again. Color is the style background color. Okay. Style. I can show this with compilation without even doing the whole thing. It's background color is, I'm going to come up with color. Okay. See, and then we're going to go const color equals math.random. It doesn't even matter what it is. Okay. I'll show the compiled output so you can see what I'm talking about. What ends up happening here is we end up grouping the effects together. Oh, right. It won't happen in this example. Sorry, give me 2 seconds. Because this is an insert. This is a separate context. Let me do this. Sorry, I have to go text content equals this. All right, there we go. Okay, it's fine. What you're going to see here is the effects get grouped together. So both the setting the style property code and setting the data on the text element are both in the same loop, but they have a guard. They're going like, if the value hasn't changed, don't update it. If it has changed, do update it. But with math.random, every time it gets called, it ends up changing the value. So it always invalidates and it always updates. Right? No, Svelte was doing the same thing. I actually put in a span, and it was a separate place, and it was still grouped. You want this is a contentious area. I suppose they might land ultimately differently, but as of today, they do the same sort of optimizations. So, yeah, I'm just kind of putting it out here. It's just this kind of reduction, as I said. I mean, we can try building in. The reactive value was the same, not two different reactive values. Oh, okay. But I mean, my understanding is that they had the same grouping. I haven't played with it, but my understanding is that they have the same grouping. But that's an interesting observation that, like, as a middle ground, you could say, you could. Well, the thing is, it's the click that's updating the count that's causing this effect to run over and over again. It just calls color every single time. And usually that's a memoized value, or it's a value that's not expensive to calculate and doesn't change, so it doesn't update. But because it's random, it gets called every time and it updates every time. Anyway, this is one of those like trade-offs where it's probably worth thinking and revisiting, but it is the way Solid's designed today, specifically because at the onset of designing Solid, I wanted to show that it was viable to scale. I actually had an article called The Real Cost of UI Components. And the difference between these kind of optimizations, of grouping, like taking a tip from the virtual DOM and not grouping, it was all the difference. And in real apps, you tend to have more bindings. So like from a performance standpoint, to me, this was one of the things that suggested that this approach was viable over the virtual DOM. It's possible with engine optimizations in the future, creating more computations could stop being the as much of a concern. But this like go back 7 years or whatever, when we were trying to prove that this was even viable, this is one of the keys to getting that performance. Because except for when people are doing, I don't know why you're doing math random, but except for these kind of outliers, this generally performs better. It's on creation. I mean, it would be like how we used to. The thing is, splitting it by specific signal would be easy to do. It's just like in this case, you'd have two effects, which is exactly what we were trying to avoid. The reason that we split on inserts is because inserts are generally structural changes, or generally more expensive, right? Like if I just insert it in here, and just put it in here, like we treat these attribute changes independently of structural changes in the DOM, and that has been a good heuristic for us. Right. So like, This is one of those kind of interesting scenarios where like it probably will never bite you, but like it is something, to be, I guess, be aware of. It's hard to document. Like this is an advanced kind of documentation thing. It's not like something that like people just pick it up. Where am I? Will just like, like how do you explain this to someone? We explain to them that all the props are lazily evaluated. That's how we explain it, right? Right? Like, I don't know beyond that how to actually explain this scenario, but it was an interesting one because I do think that it is, like, when we say stuff's lazy, it doesn't really rest with people properly. Another example of that is props children. Every time you call props children, he creates all the children. Like that is the impact of having a lazy props. You can just do that as well. Yes. Like you can wrap it in a create memo or derived in Svelte. Like there's a billion ways to solve this problem once you hit it, in the very rare chance you hit it. Yeah. Anyway. All right. Just wanted to start there because that was where, some of the conversations are happening. Another interesting one for me personally was, not that, although last stream was a lot of fun. Yeah, I talk a bit about web components a lit there. Let's not go there. But we did the Solid 1.8 release after the stream last week. We put out Solid 1.8, and as I mentioned, it was mostly like internal kind of stuff. It's really cool. We demoed it all last stream if you want to see it. But there was an interesting result from this whole thing. People started getting really weird bugs and reported. Let's see if I can find some of them. I might have closed them now that I fixed them. But yeah, like stuff like they would, I like this one. They created some SVG and then it wasn't showing up in the client. 1.7 it worked, 1.8 it didn't work. They had server render, and then instead of getting something with an SVG, all these attributes and a path, they ended up with this empty SVG element. And they're like, what did you break? Sorry, I don't have to show it. And we were also getting weird things going on with styling with the 1.8 release. And it took me a moment to figure out what was going on. And what was going on is there are libraries out there with Solid that pre-compile their client and their server, and they don't. In Solid, we have a mode like Svelte where there's like a hydratable key, and it slightly is a difference between being optimal for rendering versus like a slight de-op for hydration. The compiler code generation is almost the same, but it removes the need for certain markers. So it reduces the code and improves the speed. And what was happening is instead of shipping solid source like we recommend, people were pulling in client libraries that weren't hydrating. They're just recreating the DOM elements. So this whole time they've been using solid SSR and basically doing destructive hydration, kind of like Angular style, and not actually leveraging the benefits of Solid's like incredibly performant hydration. And the reason we never could tell was because when we hydrated, even though we didn't create any DOM elements, we would set all the attributes essentially and properties. And in this case, because it was compiled for client render, it was actually creating the DOM elements. So instead, he ends up with basically an empty element after 1.8 because we don't do any of that work anymore. And I started realizing that there is like a fundamental shift here when you're going to solving hydration. I talked about last week about how we didn't update text nodes. I asked what was the source of truth. If you hydrate something and you have a math random in it, you server render it at one number and then you get to the client and it would get another number. What should the DOM reflect? And I said classically it should reflect the client's latest one, but in reality, because in a future where you don't hydrate everything, it should actually keep the server value. Well, this is what's happening. It's keeping the server value, which is nothing essentially, and all of this stuff that should be there basically was basically being removed. So I've had to change in Solid the errors. Now when hydration fails, it has to fail hard. It can't fail in a healing way because we don't include the code anymore to heal it. Basically, we've optimized hydration to a point now that we can skip certain parts of the hydration that we can't possibly heal from a failure. I think that's actually a good direction, but it means that we actually error now, and you're going to get more, like if there's a hydration ID mismatch, it's an error. If you try to import a client rendering library and during the hydration part of the code, it starts trying to create elements on you, it's going to error and say, hey, this library isn't set up for solid SSR. So it's much, much clearer. It just fails out right away. But this was a big conceptual shift for me. Similarly, props. Think about it. Solid has this ability to go in here and go like, I want to pick something different. I mean, it's fine. what's an example? You can in Solid, everyone knows you can put a class in here and be like, I have to use like something that it can't resolve to force the compilation the way I want it to. But we have this class name helper that we use, but if you can also in Solid go prop class name, and it's just going to compile to like set the class name directly. Like it doesn't matter what this prop is. We could be prop title. I don't care. It basically just does a direct value write to the property. This is kind of awkward, right? Because for hydration, because if you think about it, if you trust the server value, you can't render props as HTML. You can only render attributes. So for like input fields, we can put the value of the input from the server as an attribute. And even though we use the props to set the value in the client, we have that initial state. But if something's always a property, even on the server, then if we start skipping the code to do this stuff because we're not hydrating, it won't work properly. I've made exception now for prop title, or not prop title, but for prop namespace, that it will always run on hydration. But this is the kind of mentality shift that we're seeing here, where like the less hydration we do, the more awkward it is for declarative JSX stuff that only happens in the client. Like you can hide it behind a on mount or a create effect. That's all good. But actually things that can't be serialized into the HTML become, more of a burden. Could you leave a flag to leave the code in that would let it recover from those errors? Potentially, but the problem is, I think, like, we're just, like, it's, eventually we get to a point, especially with Solid 2.0 design, where, like, it's just built in such a way that those code paths would never run. Like, it's just fundamental. Like, this is coming right down to the primitives. Like, one of the things I'm excited about that we've been working with Solid 2.0 is that hydration, like right now you can see this when you go client hydrations with server rendering. It's basically the same code as client-side rendering, and we think that's cool. It's because on one side, you clone a template, and on the hydration side, you just don't clone the template and you just run the same code. And it has this kind of reduction. In Solid 2.0, the actual act of doing the hydration, like these render effects, will basically, like these effects here, will basically have the mechanism for hydration almost built right in, where the idea is that render effects are going to have a pure half and an effectful half. There'll be like two functions, one to do the tracking and to do the pure calculations, and then one to actually apply the difference. And this is important because we can do all the pure stuff first and then all the effectful stuff after. Like, and this is important because we need to like do stuff like off screen and suspense, and we need to be able to control and transitions, and it's a lot cleaner to be able to control the pure side and have it pull eagerly, because most of our computations will be lazy. We need something to do the pulling without doing the side effects. But one of the cool effects or impacts of this is that you can run the front half without running the back half and still know what's being tracked. So in a sense, we'll have by design a mechanism that works for hydration, because it could just do the non-effectful part, and you just skip the effects when you're on the hydration pass. So like these kind of like the way I'm doing in Solid 1.8, which I showed, I might have not showed this on the stream last week, is that let me show you. I have helper functions for a lot of things. So when we go in here and we're hydrating and we're trying to say set an attribute, we go, oh, if it's hydrating, early bailout, right? If you're setting a class name, early bailout, right? We just added these early bailout checks and then it works. in Solid 2.0, this will just be implicit by the scheduling of the actual reactive system that hydration, this kind of minimization on hydration will just work. And taking it to the next level is when we're able to serialize those dependencies on of the graph, then we instantly get resumability, right? Like it's part of the same separation, right? You have the part that does the tracking and does the pulling. You do the part that does the effects. By separating them, we basically get this very cleanly. Anyway, but now we're in this zone, right? Like where we have to be conscious of, like, we added some new errors here in dev mode, right? Like in the template function, if we're hydrating, fail to attempt to create new DOM elements during hydration. Check that the libraries you are using support hydration. Like this is like we're being a little bit more aggressive here. And similarly, the classic one was it get next element. Let me find it. Get next element. This classic one, we used to have a lot of like different warning messages. We just always throw now. Hydration mismatched, unable to find DOM nodes for hydration key. It's just, there's no point trying to fix it. The problem is people ignore these warnings, and then I get bugs about like other random things that happen in their app. Now they're going to be like much more common. It's just so much easier. What I love about these kind of errors now, this one less so, but this one especially, is the second you try and use a new library with your SSR project, or you do something, it's going to break right away, so you know when the problem is. You're not going to be coming at it later and going, oh yeah, I had a few of those hydration warnings before, let's try and figure out what's wrong. No, like it's instantly going to be like, yeah, sorry buddy, it's not working. So like the last change you did is what broke it. All right. So yeah, 1.8 definitely had some learnings. I'm pretty stoked at like what this means for like our progression to doing less work during hydration. Though, why does this 8 look upside down? It's like an optical illusion. It looks like the top is bigger than the bottom. I don't know. It adds a lot of complexity. I've thought about it like for single elements and stuff. The thing is, cloning a single node actually is even slightly slower than document.createElement. So like you could get wins on that. I guess it's one of those things. I know like style components is exactly the argument for making this kind of stuff. I also don't like style components. It's a bad pattern for reactivity. It pushes everything into spreads, which makes it harder, more expensive to do granular stuff. So like, I really want to push to having more primitive elements. I could see, as I said, like it being able to see single element and make that judgment. It's actually fairly trivial. It just, there's like tension here where you're like, wouldn't it be great if the DOM expressions compile? See, we wrote in Babel, but wouldn't it be great to work in other things? We have it in SWC. I'm actually trying to figure out how to remove more of the edge cases so that it's almost like a standard compiler, so we can implement it in other languages. Easier. I mean, maybe it's possible we should just like all just build something really fast, like in like our own compiler, like in Zig or whatever, and just be like, that is the compiler. But yeah, right now this one isn't on my radar particularly because like, it's hard to say the impact of it. All right, where am I going here? Okay. This is a cool project. I just want to throw this out here. Native script, Vision OS, using Solid. Good read. I love seeing these more interesting projects taking fact of advantage of Solid's like granular performance. Yeah. I agree with you. There is a lot of that. Is it every single element that gets wrapped? I don't know. One of the things we were working on at Marco was recombining the templates, which is interesting. Like basically on first run of all the components, actually collect the template and then put into something so we could clone multiple components at the same time. Interesting stuff. It's just like, yeah, I don't know. It's kind of a gray area. Yeah. PodRocket podcast was good. Okay, let me continue on here because there's a few topics we got here. So I talked about 1.8. I talked about Fabio. Are we ready for this? Do I want to talk about Ryan Florence? I've been digging his tweets recently. Or do we want to? Do we want to talk about server components? Let me see here. Yeah, let's talk server components. Yes, this is the one place that like this is the biggest reason we try to minimize the impact of splitting components apart. Obviously, but this is the place where like it does actually make a difference. The larger the templates you can get to clone, the more beneficial it is. That being said, if we were crate elementing everything one at a time, it wouldn't have a performance impact if we, put multiple together or less together. But when we put multiple together, it'd be worse. So it depends on how you want to look at this, right? Either you can look at clone node as generally an optimization over a fixed cost of creating an element, or you can view it, at a de-optimization in the case, a minor de-optimization in the case that it is a single element. So it's like, yeah, I'm not. Another example is the getters that we wrap around component props. Technically, those have a cost, and as Dominic was talking about earlier, they are slightly more expensive than they should be because on classes they're cheaper. Are getters cheaper than proxies? Yes, significantly. Are they more expensive than function calls? A bit. So it's like at one point it was like 1, 3x, 10x. That was like the function getter proxy. But my understanding is that on classes, the getters are much closer to function performance. But again, splitting up more components, there's more getters. Minimal cost, but it's like something that like without, that one would probably need inlining. I did look at inlining briefly at one point, but then like there were other challenges. Yes. The key thing here is, for the most part, you don't like, it's not the updates that cause you, like if you write stuff in React, you break up separate components because of the way state updates. Like you're like, okay, I have a list and I have the separate state. I should pull the list into a separate component so that it doesn't get impacted by this other state update. And you do it to isolate the changes. In fine-grained renderers, the state changes don't dictate the split of the components. You do, but on the other hand, like yes, there is some like slight costs on splitting stuff because while the boundary costs aren't 100% zero, right? You have to create objects for props. If something's inline, you don't have a prop, you don't need a props object. You know what I mean? Like there's always going to be like slight costs for breaking things apart. It definitely is, and I did this a couple years ago. It's old, but what's it? Real cost of UI components. Let me see if I can find it. This was the original comparison. Come on, Google. Why are you being so slow for me right now? It's not Google's fault, it's Medium's fault. Lovely. We can look at my revisited one. I compare a bunch of different approaches. I talk about Vanilla.js, Solid, Lit, Svelte, and Inferno, and talk about the impact of components. Here we are. So this is the updated one. The gist is that if you put everything in one component, the VDOM library, Inferno, was way slower than the rest. Once you put them down into a reasonable place, Inferno actually jumps up considerably ahead of Lit and Svelte because it matches its update boundaries. As we push the components to the extreme, Solid's approach did have overhead. It is slower, but it wasn't. We got ahead of Vanilla because I was actually using web components for Vanilla. Vanilla is actually web components. So one web component per row, web component per cell. So in the end, Solid ends up faster than Vanilla because it's using web components, which are slow. So and I talk a little bit about the memory usage being an impact here, but let me see. Yeah, I'll put it all in one chart so you can see it. This is what I'm kind of getting at is Solid 3 was slower than Vanilla 2, obviously Vanilla 1. So you lose stuff by making more components. There is a cost to it, but comparatively between the different frameworks, Solid's approach does pretty well. Sorry, this image is not big enough, but I don't. Yeah. Yeah, it missed 1080p. Sorry about that. You can also go look in the article, okay? All right. Okay, so yeah, components are not free. I guess that it's as close as to marketing because I suggested that component costs are something you don't have to worry about. I still believe that because of the comparison I did, but they're not free in the same way that every component you make has you created an extra prop object, right? It's just in comparison of other things that you could be doing. Okay, so let's talk RCs. I have been struggling with designing RCs, as you all know. There's been a lot of API considerations. There's been performance situations. I talked about the double data problem before in stream. Serialization is, once we get into this world of partial stuff, partial hydration, it seems like all we ever talk about is serialization. And Ryan Florence actually, he's talking about loaders, but he's actually talking about RCs here. He goes, the boundary between a remix loader and the component is pretty easy to explain and understand, but we still see devs dump huge objects like user and the return value and leak sensitive information. Maybe we need to rename use loader data something more obvious as a client server handoff. RC serializing passed into client component stresses me out. It's way less obvious what's happening. We have to figure out more explicitly boundaries at the call site of the client, not the definition. So what he's saying is he comes in here, and if these weren't called client and serialize and dangerously serialize or whatever, you would not know that this is the boundary, right? You have to go look at the code and go, oh, it says use client, or it doesn't say use client. In fact, this breaks locality of thinking, which I will talk about it because that was my article today in a little bit. Because you actually have to go to another file to determine what's happening in your own file in this case. And that's pretty significant. There's a reason Quick has $signs. We might not like it, but there is a reason Quick has $signs. So I was going, okay, well, how does this look in the wild? Because it's not just what if those server components or client components aren't even in your own project? You're just npm installing. You have no clue what you're going to get downstream. Yeah, just write your server components in a different language. Yeah. Well, yeah, because then you'll definitely know the boundaries. Yeah, no, this is a good call. And actually, Astro, think about it for a second. Like, in a sense, that's how you could view Astro. Because Astros, I mean, I'm not saying like write them in Rust, and I know or Go. I think you were doing a demo in Go when I saw last. But if you think about it, like, Astro has a different templating language. There is no way to really mess that up. You're like, I'm in my Astro file. You are not an Astro file. Like, and they put client right on it. You have to go client load. Otherwise, it's not going to the client. Like, it's very explicit from the call site. Can we tell TypeScript? Yeah, maybe, but JSX is terrible at knowing what elements are. Like, I can't tell JSX that a div is a div. Like, good luck here. You know what I mean? Like, they actually have, if you ever look, I got to look at some great RSC repos, and there actually is a way that sometimes you can tell if it's a server component because it's an async function. So like there's actually like TS ignore the fact that this is an async function all over these code bases. But this was I started asking about this because I wanted to understand, because I was thinking for a second, I'm like, what is the value of the NPM ecosystem around server components? Like, why do I want to do this? And the first thing that came to mind was like, man, wouldn't it be sweet to have an API in a bottle? Like, be like import, you know, like the server actions. Like, if I could just picture, there's an export of like use server from React where it's a bunch of server actions, and you just import them into your file. And now you didn't have to set up an API endpoint. You can just like basically call them and it works. To be fair, in React, it doesn't quite work like that because the server actions can only be passed. My understanding, can you pass them? Can you import them into client components? I can't remember. Or maybe you can. I know Next was trying to do this thing with forms, but like, wouldn't it be really cool if you could just like import it and then bang, you have an API, right? Yes, this is, you're walking along the path that I'm getting to, because this is what I was thinking too. I was like, oh yeah, maybe those prefixes were a good idea. Yeah, cool. Yeah, you can pass an import. Yeah, cool. Thanks. So yeah, isn't that incredibly powerful? Like, picture you start up a new React project, don't really care what you're doing in it, client components, server components, I don't care. Just import the server actions, right? That's a huge win. Like, your whole app could basically be a client-side app. I know React has specific ways they implement it and this doesn't work, but like Solid, we have, you know, the Bling or Solid, you know, server function stuff. Like, that's pretty sweet. You just, like, picture if you could package that up, just import an API thing. That I get, but that's not what I'm talking about here. Why do I care if something is a server component specifically? Like, anything that talked to a database or anything that wrapped an API that was third party, I could just ship that API and not bother wrapping it in a component. Like, what do I gain there? Like, if you're designing your app, you have the ability to just go like async await my API. Like, why am I maintaining that? Not to mention, like, do every backend have the same request object and stuff? Like, there's a lot of conventions here that are hard to kind of lop in. So like, what am I doing? You know, so I was looking at these, and what kind of occurred to me while I was typing this, like immediately, I was like, well, maybe they're not actually server components, because you don't actually mark a server component as a server component. They just have no use on them. So they're shared components. So maybe that's the thing. You don't actually ship server components, you ship shared components. And then mark anything that has to be client just in case. You know, and I was like, as nothing makes server components, you know, server besides if you access them under a server root versus under a client root. Because the truth matters, if you have a component that has no state or anything that would make it a client component, and you import it into a server component, it's a server component. If you import it into a client component, it's a client component. Like, it doesn't, like, the only thing was, this is not a true statement, because when I looked into it, I found out that I looked at the code examples. There's a lot of async functions, because server components can be async functions, other things can't be. Dan Abramoff goes, that's kind of the point. E.g., React Marker works as an RC because it's a component that doesn't use client features. Same for syntax tilers. So in a sense, like, they could just be client components if it imported there. And this is a good revelation for me. It helped a little bit, but I mean, I still have Ryan Florence's concerns about serialization. Like, we wouldn't bother putting $ on our server functions if, we didn't think this was important to tell people when stuff is crossing the wire, right? Yeah, I heard you can technically create async client components. Yeah, although they said something like they might disallow it in the future, but it's like you bringing client components that pass API credentials. Imagine passing database credentials to a server component and setting up the back. But the thing is, you could also just interact directly with the underlying API. Like, the piece that I'm starting to get, the best use case that I came across for, because everyone showed me their syntax highlighters. Like, literally everybody that replied to this was like, check out our syntax highlighters. There's a couple cool things that weren't syntax highlighters, like mitosis, I want to talk about in a minute. And like, I saw a query thing that worked SWR one side, server components the other side. But the problem there was I looked at the library and it's like, okay, so the alias imports so that when you're in a server component land, it imports one thing. And then when your client component land, it imports a different thing, but they use the same backing API and they put it all in one package. And it occurred to me, the whole awkwardness there, why it was like that, is because you have different rules of how you do data fetch on the client and the server. So they have to split the paths and hit the same API. Where ironically, they could have just called the same API in the first place and not cared, and they could have just made it a shared component essentially if the data fetching was the same. Like, a lot of the solutions that I was seeing here were actually caused by React's API design, not like because like they helped, just because like they literally were a problem creating itself. Like, it was like the solution was for a problem you didn't need to have in the first place. Yeah, syntax highlighter. Someone's like, why do you expect them to be an NPM package? I don't know. Syntax highlighter. Yeah, this is the query state one. This is a cool library. If I understand this correctly, something that packages always is a client component, like only the client portion, not the server portion, right? Like, it works with server components. They had their version, but it was still always the client component. Like, let me see here. Okay, well, this is an API. This isn't a component. Like, I think after doing this whole look, it was kind of clear that React moved away from the dot server in a sense because they actually want the default to be shared components. Server components are a fiction. They don't actually exist. You have shared components, like just components, and then you have client components with client features. That's sort of the situation here. So that's fine, but that is kind of the scenario here. So I was like, okay, that's fine. The interesting part though is like the ripple effect this has on the ecosystem because of like the internalization and on the serialization. So I got something to throw at you guys. Tell me if I'm completely crazy here, but I was like sitting around. I was like, okay, I don't like this. Let's see if I can sign in. What am I? GitHub? Sweet. I was like, okay, let me share that in case anyone wants to check this out later. This could be worse. I just honestly, actually, I'm going to open the read-only version because it's easier to see. I just was kind of like reading these Ryan Florence tweets and stuff. Because one thing, sorry, I missed this for context. Let me get back to here. What got me onto the RSC thing was that I pay attention to retweets. Let me see here. View post engagement. And there was only a couple quote retweets or 1.8. And one of them was from our buddy here, Jay Larkey. And he was talking about how Solid's new deduping streaming serializer is something that isn't in React server components yet. And that Ryan Florence was also very much concerned about this data serialization problem. And as I said, I started reading a bunch of stuff that Ryan was complaining about here, and it was all the concerns that I've been going over on stream the last little while. So I was like, maybe it's possible to kind of, look at the API design and come up with something more reasonable here. Because what I keep on coming to as I look through this stuff is that as much as we want to automate everything and make it magical, and this ties right even into the Svelte stuff and especially React Forget of all things, is that like we need indicators and language for these things. Like Quick is right to put the $ where they do because we need to know about it. Even if they can automate stuff, the developer needs a language. And because the developer needs a language, like these things can't be invisible. Like, so automation doesn't mean invisible, which makes it still a thing, which means that we are cognitive of a compiler and a compiler cost. Anyways, the combination of these kind of tweets has got me back to thinking about what server components could look like, and if this is just like a stupid idea. But I wanted to kind of put out here what my concerns were after seeing this. Right? Yeah, everything comes down to partial hydration. We need why Quick has a $, and Bling has its $, and islands are no difference. But React right now has these 3 mechanisms, maybe 3.5. Use client, import me as a client component. Use server, I'm an RPC call that runs on the server, only in server components. Import server only, something else I think in next, I need to be on server or else. And then they have async functions, which are, I think, just for the server, although technically not, but should be. So this is how we navigate this space. But there's impact of these decisions. It's not clear from the outside what type of component you're dealing with. The current ecosystem needs to go add some use client all over the place, or consumers will be creating extra file wrappers. The fact that they have to go put the use client is fine. Like the thing you have to understand is people who want .server and .client, if you're thinking from a package standpoint, can you picture forcing everyone to go into their libraries and changing their extension to .client? The problem is the client components are the special ones. So you can't just make, well, we'll leave the client as it is, and then we'll add .server to the server functions because of shared components. That only works in like the Astro sense where like you're an Astro and there's nothing you can do about it. But if you want components that can be used in both contexts, then those are the ones that shouldn't have the extension. Which means that the file naming convention only works if you're starting a brand new ecosystem. It would basically break the whole React ecosystem. Okay, moving on. It's clunky to wrap client-side higher order functions around RPC calls. Picture client cache. Yeah. This doesn't matter much because you only use cache calls in RSCs. But what I mean is like, I'll show an example a bit later here, but like it's very weird. If you put use server at the top of a file and then export a bunch of functions, then if you want to use React's cache API around those functions, you need to then import them all, wrap them in the cache API, and then re-export them again probably to use them in the locations where you want to use the shared calls, probably. Like you could cache them in line, but like generally the pattern is you cache at the declaration site. Now, again, with RCs, you're doing all the fetching on the server, so you don't have this hawk problem, but I'm thinking very generalistic, like if I was going to try to use the same solution for CSR server components for everything, right? Also, they're not configurable. Like, how do I change my server functions to use get versus post or, other things? Like I don't really have much at my disposal with use server. It's kind of invisible. Like there is the async local context, but that only exists on the server, not at the call site. So you don't have the ability to configure them with their APIs. This is a big downside that we saw with when we were working on Bling, which is why we kept on going with the $ and not use server there. And then finally, use server and use client look the same, but they aren't. Like they're actually completely different concepts. One is for a server RPC, one is for client components or client root entry. So I was like, okay, I'm going to put this out to you guys first, and you can tell me this is just a terrible idea. I'm the kind of person who doesn't care about typing. A lot of people were, we just had a whole stream about like how far someone's going to go to avoid typing parentheses, right? I'm being a bit facetious, but like, I don't care about that much. I was like, I noticed something the other day, and I've been watching this for a while. There's this idea, and it's coming out in TypeScript 5.3 because it's already a stage 3 spec of import attributes. If you're not familiar with import attributes, it's a feature where runtimes can say like information, metadata about the import. So, TypeScript doesn't care what this is. And TypeScript's fine with this, but your browser probably found it. So like the question is, and this is a big question here, like I don't know if runtimes will, like obviously type means something, but if you put something else here, like you make up a field on this metadata, like I don't know if browsers will choke on it, but it's an interesting idea that you could tell people how the import should go, like what it should do. Sweet. It's all you roll up for. Let's go. Yeah. So, okay, sweet. What I'm getting at is, what do you think of not having client components and go after when you specify on the client prop? Yeah. I'm almost on the same page, except yes, I'm very much on the same page. The problem right now with Astro is you can't just like switch the shared components are kind of a weakness. So let me continue on with this. Okay, so what if you could, like Astro does it on the component, and that's a call site. That's probably a very good thing. But then like you're adding props to components that don't naturally have them. For me, I was thinking, wouldn't it be natural if you could just like say island true or client true, like something at the import time? That's still enough that when you're looking in your local file, you're in your component, like you're looking here, you can actually see without looking for it that, like this is a client component. You specify, you can put all your client components together at the import site. Plus, as I said, it's more representative. Like you make the choice on the outside, you tell them that, right? So, I don't know what this is. I don't know if we're allowed to do this, but this is sort of the idea. If we could start like this, that's pretty sweet. And then I was like, okay, well, I'm playing around with the dollar sign. You put the dollar sign at the end. So originally we put the dollar sign at the end because of quick, and we were like, okay, we could like kind of make different versions of it. But these things aren't really composable in the classic sense. I think they need to be more visible. Maybe cap it all, put it first. I don't know. I saw Svelte macros. Maybe, that part isn't that important. But I was like, keep server functions as server functions because they are not the same thing. As long as there's a way to make these very obvious. See, right now, this is all black in the syntax highlighter. This is not obvious to me that anything special is happening. If we can find a way to make the macros really freaking obvious, I'd love it. But what's cool about this is with server functions, you can literally do this whole thing. You can go cache, server function, some server wrapper, some special behavior like server, the function that you have there, and then some config options. Say, I want this to be a get, not a post. Like you could literally do all of this stuff in line with the server function. If you're using useServer, well, this is what I was saying. In one file, useServer do this. Another file, import it, then wrap it, and then still no way to do config and do it. And you might be like, oh no, but you can use server inside the function. Trust me, if you actually go in and use the useServer inside the function version, I mean, I could write that out too, but it's like it's much clunkier than being able to do this. There's a reason. You could say that, oh, useServer is not that bad. You can still do it, but there's a reason why I'm pointing things this way. Okay. So yeah, concerns of bundling, you extract closures and no surprises, terms what gets included. I don't know what the convention is, but we all want macros, whether they're like Svelte state or quick or whatever. So I feel like this is very much a macro thing. Then, okay. Compiler hints. I don't hate use client, use server. Like use strict is pretty sweet. But the thing is, a lot of times you might not, like, I'm hoping that these things just, what I like about both this and these are they can kind of be ignored if you don't support the thing. The idea is these are completely optional. If people add them to packages, great. If not, well, then limits options, but no harm. Basically, if you try to import a client component that isn't marked as use server, unless it does something not allowed on the server, like read context, it will work. Sorry, if you try to import a client component that isn't marked as a server component. Sorry, I'm trying to figure out how to. This is a bad explanation. What I'm trying to say is these are hints. So like if you try to import a component in a client component and it has use server on it, that's immediately the bundler goes, sorry, you're trying to import a server component. It's just like a way that like you're saying this is definitely on the server. Now the truth of the matter is, if you didn't put this in, it's probably going to fail at runtime anyways, right? Because you tried to do that Prisma database fetch and it's not there. Similarly, if you tried to in a server component, in a server context root, and you try to import this component and it's got a bunch of state, like, I don't know, the bundler could fail there as well if you try to import it, because you're saying this definitely has to be on the client. Maybe it uses context. Like, the thing is, if you're using context in a client component, it's going to fail when you're trying to use it on the server anyways. It should just at runtime. But this way, the compiler and the tooling and your IDEs could actually do smart stuff if they see these flags. The criteria for this, naturally, like, you could just not do it. See, what I was thinking for a bit, and I was like, why do we need use client? Like, state doesn't matter. We've server rendered stateful stuff forever on the server, and it not having state. You know, like, you can go to Astro and not put a client load thing on it. The only thing that actually breaks on server components is actually if you have different patterns for data fetching, like React, which I 100% want to avoid, and if you read client-side global state from the server, that will be 100% broken. We showed that on the Astro stream. We showed that a few times. So as long as any component that like uses context, like, the thing is, it will fail and people will know at runtime. But this goes, I don't want it to fail at runtime. I want it to fail at compile time. You just mark it on optionally. It's just a helper. We can ignore this even exists for the most part, but that's kind of the idea. So what does this achieve? Well, it's clear what components you're dealing with from the outside for serialization purposes, because you're saying, I want to import this as a client component. Use client is optional, although whole files modules would be imported as either client or server if, you know, someone need go in and do it. So like, if you have an npm package and they haven't updated yet and you tried to import it, unless they're using a feature that was client only, like context, it would work under the server components, or vice versa. And you could do that in one line instead of making like a wrapper, like use client, import this, re-export, you know, like whatever. Like, you don't need extra files. It's literally just the import statement. It's easy to wrap RPCs with higher order functions. I already showed that. RPC behaviors are configurable. And finally, use client, use server are equivalent and opposite. They mean the exact same thing. So I addressed all the points above. And I've closed off saying, I think we need to know about serialization, which may prevent us from ever automating these things completely. Like, use client, use server in this proposal could be unnecessary at some point in the future. Like, if we had a compiler that can look at what we were doing, you wouldn't need these hints. But I think you would always need the import statements on the outside or the server function, because you need to know as a developer what you're dealing with. You know, and I'm okay with that. Well, lost a few people there, but I hope you follow it. I've already written a lot of text, but I think it's the best proposal. Mainly, it can be used outside of Solid and can be used for RPC calls, for our client only, but the same check can be used both its own. Yeah. I mean, to be fair, React thinks their version can work inside and outside of React as well. So, can you explain why server components cannot be used in client components? Why? This has to do with prop. It's very important that you can't pass client-side props to server components, because there should only be a single server root. Ultimately, you can say on the server choose to render parts of it, but you don't want to have back and forth waterfalls because of prop change. You don't want to like essentially have a server some kind of change, go to the server, render the server components, get to the client component that has server components in it, but because you aren't running the client component because of it depends on global state or whatever, have it go back to the client now, render the client component, realize that its props have updated for the server component, go back to the server, do that. Like, it's very important that you can't pass client props to server components. So we use transclusion, or what the term is, to prevent that, which means you can pass them through as children, but they cannot be imported inside a client file. Okay. But why is there not hydration server side? Not following it, sorry. Yes. Isn't marked to use client. Doesn't get imported as a client component. It just ran as a server and never had it. So yeah. That's basically what I'm suggesting. There could be a runtime error if you try to use certain features, but state is not enough of a feature. Maybe on mount, like if you have effects in it, we could be like, look, you're trying to import an effectful component only on the server. There's no effects on the server. Maybe it's a warning. I haven't quite figured out the details there, but we do this in Astro a decent amount of time too. What about client components that wrap other libraries, like a chat window or anything else? If they're client components, then wouldn't they be completely client components? Yeah, I'm not quite following, John. Like, the server component tree, single server root, you can have multiple client roots under them. Once you're in a client root, you can pass server children through and kind of do that, but like, once you're in a client root, you are in the client root. You can't get out of it, so to speak. So any existing library that is a client library will work fine because it'll just go under that client root. Yeah, maybe. Okay, people are losing a few people here. Let's keep on going. Oh, yeah. Yes. Okay. Yeah. Yeah. Then it won't work. Right. But what I'm also suggesting is like, it also won't, it kind of won't, it also won't work. Like you should just import as a client thing if you need to import as a client thing. Right. Like, yes, there are situations where it won't work properly if you do it, but like, all you have to do is add a use client somewhere, and then you make sure it happens. Cool. Okay. Let me continue here. So we talked about Ryan Florence. DHH. Oh man, I laughed so hard when I saw that. Are we at DHH time? Yes. Exactly. Yeah. I'm trying to think if I have a good stream on this. Honestly, people ask me this every time because it's like the thing they like really struggle with. I'm trying to figure out. I feel like I've explained this for like 3+ hours across multiple streams. I'm not going to do it again today, but I've definitely talked about this before because like islands have the same restriction like in Astro. Basically, any system that's worked like this arrives here eventually. Okay. Let's see here. Yeah, sorry. Just trying to get back to where we were because there's a lot of stuff going on here. Yeah, we talked about that. Before DHH. No, I'll leave this one last. Let's do DHH next. I think there's nothing else here. Okay, cool. So, DHH decided to do keynote for I forget, it was some Rails conference, Rails World 2023. Yeah. Sorry, I'm just still reading comments from this. The lack of isomorphic data fetching definitely makes this problem. Yeah, that's the thing. I'm assuming here, and it's because of solid, like that data fetching will look the same on both sides. And that's what I've been working on. So like I'm not saying this is like the universal for everyone. I'm saying solid can pull this off because our data fetching will look identical on both sides. Like our patterns. And those won't qualify it as being a client shared or server component. Yeah, that's the sort of idea. Exactly. I'm still working on like exactly API there and stuff, but yeah. Okay. So he talked about a lot of stuff. I just want to fix in on the no build conversation. Because it's a funny one. I feel like there's been this growing contingent, and it's not surprising, of web old timers, people who support web components. Like there's alignment of people who, because I feel like it's largely because they're positioning against modern declarative JavaScript frameworks and like the stuff in it, that they're kind of predisposed against this. And don't get me wrong, there is a lot of complexity that comes in these build processes. If you have maybe like I could see a scenario where, depending on the size of your team or whatever, like the impact of build times and all this infrastructure around builds could be prohibitive. I've actually, like, it's funny because like we build tools for our tools to get this stuff working, right? We're constantly working on improving the, it's not just like our HMR. Like we spend a lot of time, trying to make sure that the development effort, environment works really quickly, right? And the funniest thing is when we used to develop in JavaScript and HTML on the web back in the day, you would literally update an HTML file, refresh the browser, and you'd see it, right? And like, it's not hard to picture having a script on the page, auto repolling it or whatever. Like you didn't need to build anything and it was super fast. So I can see where this is coming from that perspective. There's also, when you have, people who, a lot of the same group who says that single page apps were like a 10% improvement over multi-page apps. I don't know what world these people come from. Like, I mean, I do, but I don't know how anyone could say that with a straight face. Like, don't get me wrong, there are tons of shortcomings with single page apps. Talk about that a lot. But like to actually like just straight face be like, yeah, it was like a 10% improvement rather than like, honestly, it was like a 70% improvement. I think that I'm more concerned about the advice being given here, which is that, lean on HTTP2, import maps to, bundling, no build is something one can do, but you can never pretend like it's better ultimately for your end user than build. You can say that perhaps in your environment that the cost of build for your developers, is extensive, right? I don't know these scenarios which would get there. Yeah, it's funny when spec compliant people get in there. Multiplex recruitment is not more efficient than bundling. HTTP3 has a fix and maybe prove bundling is the thing of the past, but no one has tried HTTP multiplexing in a sim server as far as I know. Okay, I've talked a lot about in the past how it's more than just being able to pull the right modules out. I talk about how dead code elimination can happen within the middle of a function, how you can reduce bundles, incredible amounts. The way you write your code when you know that it's going to run through a bundler can be optimized in a way that no inbuilt tools can do. We've done the demos on stream, but like he's clearly doing this to be sensational, but like I'm getting his argument is trying to say that it's good enough. I'm going to find another tweet of his in a minute. Let's keep on going. Yeah. Malte from Vercel. Been there, done that. Straight up does not work. In HTTP2, the request overhead is still very substantial and there are concurrency limits. Plus you get waterfalls and inefficient compression. There's no way around bundling for high performance websites today. Like, yeah. I agree completely. The funniest thing is, at some point, this discussion, I don't know, Jay Larkey, if you're still around, you might have it for me. It got turned into Lighthouse scores, which I would love to actually see. Let's see if we can find DHH's post on the Lighthouse scores, because let's keep on going. Let's see if we can find here. Yeah, this is what he posts. How we built Hey wasn't feasible prior to 2020, before import maps. So if your mental model of the web is soaked in the possibilities of 2020, I understand your skepticism, but please don't let it restrict your ability to appreciate progress, right? he points out, I think here, that he uses local desktop lighthouse scores. I can tell they're desktop because largest contentful paint is never like the response time. Let me see if it's in the article. You can't get a first contentful paint of 0.4 on mobile. You could serve a blank page and you don't get 0.4. So these are desktop scores, I believe, from his local, computer. And like there's some comparison. Maybe it wasn't this one. It was in the tweet between Gmail, because Gmail got 90. Again, Gmail. There's no way Gmail gets 90 on mobile. Okay, yeah. Well, I'm getting some shares here. Just a second. Let me see if this is the right tweet. Thank you. Yeah, this is the one I was looking for right here. Yeah. Yeah, this is 100% desktop. You got to use something like WebDev, web.dev, HSpeed Insights, and you got to use mobile scores if you're actually going to take it seriously. But even so, let's look at what he's suggesting here. He goes, we sent just 500 kilobytes of JavaScript uncompressed versus Gmail's 10 megabytes. There's a couple problems with this. Like, besides the fact of Gmail's legacy here, let's ignore that for a moment. The thing that kind of stands out to me about this is like, we don't know the capabilities of Hey being the same as Gmail's. Like, picture if Hey doesn't use as much client-side interaction. It relies more on doing like HTML partials or something, right? You're going to maybe send less JavaScript for that, but it'll be visibly clunkier for the end user to use. In fact, most people that I remember when Hey was launched said that it felt clunky. So like, you can't really compare it here. And he's like, we send only 500 kilobytes of uncompressed JavaScript. Do you know what that tells me? That someone could build Hey. First of all, they could minify and compress it. Second of all, it's likely that if they were using modern front-end frameworks that leverage, these technologies that let, like more granular technologies, perhaps things like, islands or resumability, that with a smart compiler that's able to like do this stuff. First of all, the code's probably more maintainable if he's doing like crazy jQuery type like partial JavaScript insertions in different places, like using stuff like Stimulus, which I believe is what they're doing. But like, I would not be surprised if someone could make a Hey clone in less than 40 kilobytes of compressed minified JavaScript. Like, just because 500 kilobytes is good enough for him, I bet you someone with the build tools could make something 10 times better. Like, that's the problem here. It's one of those, like, if you can do it, I can always do it better. Like, that isn't a question here. The build tools do just make it better. There's basically no possible way that they don't. Like, because of what they can optimize. Yeah, you see solid movies times through solid email. Like, let me see if I can. Is this the code for the page controller? It's Stimulus, isn't it? Let me hear. Yeah. Yeah. Okay. So their approach to JavaScript is actually a small one. I'd say it's actually it's good in the sense that it is going to be hard to match them on size if this is what their code looks like all over the place. On the other hand, I think I can figure out what this code is doing by looking at it. Right? I mean, this is a very simple example of where they're getting they're seeing if the anchor element is active, and then looking at the scroll height, and then getting the bounding size of the entry element, and then shifting it and setting margin. Yeah, I mean, my point is this is what happens when you like don't use declarative JavaScript and use imperative JavaScript thing. It's like the jQuery soup. I'm sure like this approach is possible to be smaller, but like scaling it is a different question. But let's pretend it's roughly comparable, because I think Stimulus as a library is about 20 kilobytes, if I remember. It's actually rather large. I remember I was doing a benchmark and I was like, it's funny how much smaller Svelte is than Stimulus when they're built for these purposes of doing these small little widgets. But what I'm getting at is that, like, sorry, where are we here? Is that like it's a funny argument. You could say it's not necessary, but you can't say that it's not better. So I guess this is the drama of the week. I just hope people don't fall for this too much. Yeah, sign up for Hey. You know, Hey costs money, right? Yeah, like this is. Yeah, the sell guys are right in there. Yeah, yeah. I mean, like, let's face it. Like, this is like when someone makes a toy demo and then compares it to the real thing and goes like, mine is so much faster, right? You know, the funny thing is this works for us often when we make frameworks. People come in and go like, I did the rewrite in Solid. It's so much faster than my old site. You know, it's like, yeah, well, because you've learned something from there. You don't have the legacy. But even without that kind of scenario, the same things that would make Hey smaller would never get detected on Lighthouse, right? Like, essentially, if Hey reloaded the page every time, had the clunkiest user interactions, that would have less JavaScript. If it was hard to maintain, that would have less JavaScript. You know what I mean? So, like, you could never actually compare this. And yeah, anyway, it's fine. Like, this feeds in the fire a bit, but it's just it's fine. I think there's a group of people who are worried about the complexity of where things are at right now. So they'll take a performance hit and say something, if they feel like they can avoid that complexity. I don't know if I want to be the person who's maintaining that stimulus code. It's 1 minus to take from 10 to 300. Yeah, I mean that as well. So yeah, I mean, whatever. I don't know. When people come in with this, I haven't seen a legit no build argument. I have to admit, like, I remember like somebody, Brian LaRue, I think, was all like going off about like, guess what, guys? You don't need minification. You can just zip it because, and he used CSS as an example. And if anyone knows anything, CSS is like the least minifiable thing. And he's like, look, minification plus zip versus just zip only made a 10% difference on size of the CSS file. And I'm like, but JavaScript is not CSS. You know what I mean? Like, so, have you ever seen what Terser does? Like these things, Terser online. I don't have a code example for you. I wish I had a code example. It when it minifies the variables, it looks for the most common characters used in your code that it can't minify and makes the variables those. Like, it actually improves your ability to zip. Like, it looks for like, yeah, it's fine. It's just like, this is just it's so, like, I don't know. I actually saw an interesting tweet from Andrew Clark, who's a obviously core React maintainer. Andrew Clark, he works at Vercel now, but he was saying something along the lines of, oh, I think this one's old. I won't be able to find it. He was, oh yeah, here it is. If I had to start a project tomorrow and I were to prohibit it from running server-side JavaScript, I'd probably use HTMX. However, if I had the time and resources, I'd build an RSC runtime plus framework for whatever server-side language is available to me. So basically, the thing is, in a sense, HTMX plus classic SPA thing like SvelteKit is what server components are solving, except they're doing it in a consistent singular way. Like that's a way of looking at this. Like there's elements of HTMX that are valuable, but like wouldn't it be great if you could actually just have it part of a single system? Yeah, see, client components would be unchanged, but you just write your server components in a different language. Not as nice as all JS, but the programming model would be largely the same. And then someone's talking, well, then all your backend has to be, a single server. And so, yeah, I'm disagreeing with that model. Yeah, and he links this this hypermedia versus data APIs. And there's a lot of good arguments here. I tend, even if I told you I have almost no use for HTMX, I think they have good ideas, right? But we need more. But like essentially, yeah. If you haven't read this, it's talking about the benefit of actually passing the markout back instead of like having to process the data on the client. Because especially even with stuff updating, because then the ownership or componentization can be independent. Like because the problem is when you have a front end and a back end, you have this like interesting challenge of like you have to update the code in both places, or like the API changes and this talks about like if you actually serve what you're finally going to serve, then like there isn't that kind of split. And that's the philosophy actually behind islands and server components as well. Yeah, exactly. Yeah. So right. So like basically like my guess is if Svelte had something like server components, you just wouldn't need HTMX. It'd be like same benefit, but just like more integrated. There's differences. Like you have to be able to solve state preservation, right? Like all these partial and like island type solutions have to be aware of this. And because like this is a challenge for Astro right now, and it's going to be a challenge for any of these kind of hybrids. You can do simple things, but when you try and do the hard things, it's trickier. I'm not sure. I mean, Dom suggested that I think they're thinking, when you go compiler thinking, you go down where Marco and Quick is. I don't know that these are mutually exclusive though, because as I was saying earlier, people need indicators. They need to understand when they serialize. They need to understand the rules. You need a language for it. This is the same argument I made about signals, right? Like why any compiler like React makes, like for React Forget, ironically, even if they're saying like we've hid the reactivity or whatever they do, it's going to look like signals essentially. Oh, sure, you don't call a function. Like you don't call a function in Svelte either. Like, you know what I mean? Like it doesn't change the fact that you're aware of the data graph in a local context. So like on the same size that, yeah, now stores are fine. But the problem is, okay, check it out. If you have, once you get into a part where you're not unloading the page, the MPAs are fine, but once you get to a point you're not unloading the page, you can't client render the islands, or sorry, server render the islands anymore on the server, because they could possibly read from state that is different, like doesn't exist on the server, maybe a different thing, unless you're serializing the data back and forth, which gets us back in the .NET days. I talked about this on a previous stream. Like it's, unless you have a more complicated system, it's basically fundamentally broken with global state. well, unless you're always client. Yeah, it's interesting. You could always client render in that case because you're the one making the call. So it's kind of like you server render the page initially, you do the HTMX call. Because it knows that an HTMX call, it then doesn't render the client components. So it doesn't hydrate, but then renders the client components. Yeah, I mean, I could picture how you could wire it up yourself. I'm just saying, like, picture that just all actually just working out of the box just as is. Not a ton. I did very much enjoy that talk. To be fair, Dave shared with me a talk that I think everyone should probably check out. It inspired me to write an article this week, in fact, and let me see if I can find the link to it, because I'm just looking at it off screen because I don't want to share my personal DMs with Dev on here. Here we go. Yeah, let me just copy the timestamp. React core team member talking about design for Forget. And when I watched this talk, it very much, sorry, let me post this in chat. Because as I was watching this, I realized that all the principles that he made the Forget compiler possible, that they were very proud of and what they were trying to accomplish, already existed in our signals today. Not to say that the work they're doing is pointless, but it's like, it makes me wonder. But yeah, what is it? Quick, you never know where you are. Well, see, that's the whole thing, right? People, if you can automate it, you think you're fine. The knowing where you are part is why I don't think they're mutually exclusive. Sorry, talking about server components here for a second. I do want to talk a little bit about this on the Forget talk because it directly influenced my article. But to kind of finish with the DHH thing, I'm going to pull out Excalidraw for 2 seconds because, I mean, I don't know how to explain this best, but like I keep on thinking that what usually happens is we start, like when we're doing standards, we kind of start here, right? We start here and we like see, let me say start here. Okay, why is this? Let's make it transparent. So I'm going to start here, okay? And then we go, okay. We're like, wow, wouldn't it be amazing if we could go here? Goal, right? Maybe I should just call it like goal number 1, right? Or it's not even goal number 1, it's initial goal, right? This is always what happens, right? And this happens with standardization process. This happens all the freaking time. So what ends up happening is we're here, but maybe we can't act on it because where we are. So, we're the legacy. If we're like legacy software or the big player here, it's going to take us a while to get to this goal, but everyone here kind of agrees it's the goal. In the meanwhile, there are small players here who are kind of sitting there with you and going, yeah, that's really, really cool. And while you're kind of inching up here, you're like, I'm going to get there one day. They kind of go, oh yeah, I'm going to get there. And they get here, and then they get to about here, and they're like, crap, this isn't actually what we want. We want this. So in our second time lapse here, these guys are like, okay, now we're ready to actually make some good strides. So they get to about here, and these guys would go, okay, yeah, this is where we were at. Yeah, this is much, much better. Okay. So I'm going to zoom out a bit to keep our diagram going a little bit. And then what ends up happening next is these guys are like, oh, okay. You're gonna get. I mean, the cycle repeats again, is what I'm gonna try and show here in a second. So these guys go and they get here, and they're like, next initial goal. Okay. All right. And again, these guys, let's go blue. These guys are like here, making a little bit, it's accelerating. These guys make their initial start, but actually guy over here, small guy, goes during the same time period, goes, okay, I'm gonna get here. And then they realize that there's something over here that, funnily enough, is sitting kind of in the same range as these guys. So what we end up here with is, okay, let's go to the next one. Arrow happens. These guys get here. These guys get here. These guys finally get here. Okay? Sorry, a lot of drawing, but with this whole hey thing that's going on right now, it's like this is DHH and he just got here and the people over here are like, you're on crack. Like, by the time I even started, I already knew that this was not going to work. Right? And yeah, these guys are wrong, let's say, let's argue that they're wrong. You guys can battle each other a bunch. But like, I sometimes feel like, picture if this length of time of when this happens is like a decade. Like, how long have most React developers been developing on the web? Like, people don't even remember what these guys were thinking back then to even get there. That like, it can even sit, as I said, over where that initial goal was. But it's like, trying to tell me that this is better than this is insane. Hopefully this diagram makes sense to you. That's the way it makes sense to me. But this is kind of the thing. And I feel like in some cases with DHH these days, this cycle has happened like maybe like 5 times, and they're just getting to here, and like we're like way up here off the screen, and we're just like, what? Anyway. Okay. That was probably a terrible diagram. But like that's how I want to summarize DHH. Like I can summarize a lot of things like this. This is web components too. Yeah, I mean, it just depends on what you're talking about, right? Like, we just keep on doing this. The funny thing is, sometimes there are people here, so I'm gonna make this white, that show up kind of in this zone, and they're like, they don't want to go here, but they realized they miss this, so they're like trying to like, I don't know how far I can take this diagram, honestly, but like maybe at around blue time period, they start kind of going off here, right? Right. So if you want to think, this is what I view HTMX is, by the way. HTMX is right here. But like these cycles happen, and yeah, anyway, sometimes we get to here before we get to here or get to here, and we think that like this is, you know, it's important, it's in the right direction maybe, but it's not. Yeah, anyway. I think I've taken this diagram as far as I can take it. Hopefully this makes sense to some people. All right. Let's get back here. Is that it on DHH and no build? It's just funny reading the chat responses because like there are a lot of people very passionate about this position, and I have no clue what they're smoking. Okay, while I'm in Excalibur, I want to do something really quick here. This last stream, I nitpicked this graph about find to course, and I can tell that it's been updated, but I want to draw this graph myself for a moment, just because I don't quite agree with this, and it's better than it was before. But let me draw it one more time. This is not a stab at anyone. I want to take my own shot at drawing this graph. Okay, so let's get back to 100%, and let's try this again. So I'm going to make a double-ended arrow. Where is it? Arrow. Okay, that's one end. And all right, there it is, double-ended. Okay, cool. All right. If I had the cool logos and stuff, it would be good. There's like a temptation to try and do really bad hand-drawn versions of the logo. But like, this will only take me 2 seconds to do here. God, it's like, how badly can I draw the React logo? It's like, can I use the shapes to cheat? Can I like do like... I'm like looking for reference. Yeah, I can't even, can I angle it? This is like probably a big waste of time actually trying to make the React logo. I did it. Can I scale the whole thing? God, see, pretty cool app. Okay. Okay. React logo. What's Angular? It's like a big letter. No, you blue. No, damn it. Oh, man. Blue. Angular. We're just going to make Angular a big A. Yeah, that sucks. What's this Angular logo look like? It's a white A on a red shield. Okay. Okay, we need to make the shield. How do I make the shield? I don't think do I just like free form draw the shield? Can I actually, actually, know what I can do? I think there's like a, yeah. Okay, so it's like, if I press, what's it? What is it? No, that wasn't it. If I press option, maybe, whatever. Honestly, why am I drawing this? Oh, there we go. Whatever, it's a shield. Okay, stop doing that. Escape. I don't think I can fill this though, right? No, whatever. We're just gonna put a white A in the middle of it and we'll know that's Angular. Okay. Angular. And then view Oh man, I don't even want to think about this. See, damn it. How did... Okay. Sorry, view. I think I'm just going to make a big V. How like the longer this goes on, like the harder, the less likely I'm going to want to... It's like a... Can I just make a really fat marker with a pen and just be like, screw this, just be like, where is it? Stroke width, and be like, and then take like a blue color and just be like, okay, view. There we go. No. Svelte. Let's do the same thing for Svelte. And then solid logo. Like draw a blue duck. Or 2 teardrops. That'll be the easiest. Let's do a medium size and do like... And then Quick has a logo too, right? Let me see. Let's look back here. Quick. Oh man. That's like just too hard, isn't it? It's fine. I'll worry about Quick later. They're not apparently on the first graph. Okay. So roughly speaking, this is where the frameworks classically were from, what is it? Fine to coarse. Actually, not coarse, it's like coarse, right? But if I was to draw not today, but in the next 6 months, it looks like this. I just wanted to fix this up here. It looks, in my opinion, like this. When we talk about View Vapor and Svelte 5, it actually looks like this. These ones are stacked. These guys are here. I think. And I don't know what... Yeah, Angular stacked with Quick might be fair. I'm debating putting Quick right here. Let's see if I could put the logo in here. I don't have... Oh, this is going to be hard. I only have blue. I don't have like purple. So it's like approximating the Quick logo is actually going to be particularly hard because... Oh, don't do that. Because it's like this. Get a little bit tip here. All right. It's like a lightning bolt. Oh, okay. Sorry, guys. This isn't true today, to be fair. These guys haven't moved yet. Like Svelte 5 will move it. But like, anyway. Moving on, I only got one more topic today. Sorry. Done with the drawing. Yeah, blue semi-transparent for the purple. Yeah, like. All right. Last topic today I want to talk about is the article I was working on, thinking locally with signals. And this article is a big love letter to React. I was watching that talk about React Forget, and I was thinking over and over again while I watched it, I was like, it's amazing how big the combination of factors for React led to its success. Some people talk about like meta and, like that backing bit, like even technology wise, like it wasn't the actual tech itself, like the virtual DOM or the JSX, but like the way they combine these patterns that made it really usable. The lucky thing is everyone else has been able to adopt those patterns over time. And the reason I wanted to talk about this is I do very much strongly believe that it's important design aspect to allow people to have this locality of thinking. We got accused of this, funnily enough, when the whole signal stuff went out, like the Devin Gabbett tweet about like, two-way binding and stuff. But like, we don't have two-way binding. This is not a thing. And I thought it would be worth actually writing an article. I did do like all those articles before, but actually just talk about this idea of locality of thinking, because you're going to hear a lot more of this, I think, because this is really the emergent property that happens when you basically attack or combine the principles that we've come to believe are the correct choices in modern web devs. Because if you can look at a single component and be able to be productive without looking at the rest of the code base, that's a huge boon, right? It allows new developers to get ramped up faster, right? It allows features to be built in isolation. It even lets you return to something maybe you wrote a year ago and then understand what it's doing, because it's like, only concerned with the modular piece it has. So I think this is an incredibly important aspect of React's design that really made it what it is today. Like, it's not about the VDOM or any of that kind of technology stuff. This is React's legacy. And people don't realize it, but unidirectional flow is probably one of the most important pieces of modern UI design for this reason, right? I think a lot of times because we think of React and we think of immutability, we kind of like assume that that's the only way we could possibly do it. But like, let me explain. Unidirectional flow is really important to understand what's in front of you, because essentially you need to have trust in what your code does. When you import some function and you don't know, like you looking at some data object you have, and then you pass it somewhere and you have no clue what's going to happen to it, there's no way you can do your work without actually looking at what this does. So this is large part of why unidirectional flow is really important, because you want to be able to know about any possible mutations that happen to the data that you possess. Yeah, exactly. Yeah, Elm, it was completely on this. Or Flux. Yeah, I remember Flux, right? But something that we kind of realized over the years is that it isn't just like straight, pure immutability required to actually pull this off. You can actually get the same impact by just having read-write segregation. Like even React itself, they tell you to be immutable, but some people were mutating it and forcing re-renders, especially in the old class component days. So like when they went to hooks with read-write segregation, it actually enforced it even more so, because I don't know if it was intentional, but like without the ability to pass the thing that can be changed, like forcing the how should I put it? without being able to implicitly pass something that can be modified, you make all mutations explicit. And this is one of the things that makes React so powerful. I use some components as an example here in Solid, but it's the same function problem again, right? If you have title and set title and you only, pass title, then there's no way some component can change it, right? Like assuming that this is the mechanism for change, you have to call set. And in fact, in Solid, we actually tell you to call the function and pass by value, even more so, because I'll get to that in the next section. But this pass by value is a very clear indicator that, like, hey, like if you're getting, think about it. If you have a title like a string and you pass it in, someone who gets it on the other side, like they get the variable and they try and change it, like they're not going to change your version of the variable. They're going to have their own version of the variable. So pushing towards like a place where you're saying I'm passing the value mentally gets you in the right mindset that like these signals aren't things that you pass around from a local scope perspective. Technically behind the scenes, we do propagate reactivity, but for you authoring, you just look at what's in front of you. If you want the title to update, you call set title. Wow, I think I have my first troll. This is awesome. Thank you. Anyways, as I was going, essentially, Svelte ruins that we saw earlier is kind of the exact same thing. We saw this, right? Title. If you pass a title through, like you can tell from here, you're passing the value of title. This is not like a signal. There's no way that someone could change your version of title. And again, if you want to update it, you pass an updater function. So like in the end, this ends up being identical to the Solid example, except it's using a compiler for a little syntax thing, but it actually does exactly the same thing effectively. You're going to ask if the difference between unidirectional flow and read-write segregation? In a sense, not like read-write segregation, I guess, doesn't require stuff to flow, but yeah, I mean, that is kind of the key to it, right? Up and down. It's often associated with immutability, but what I'm trying to say is that immutability only has to be a control factor. It doesn't actually have to be like a property of the actual data itself. Like you could have deeply nested reactivity like a store, which can be mutated and still be fine with read-write segregation because people can't update the different portions, but you could do fine-grained updates from the top and have it still work. So yeah, I guess read-write segregation and unidirectional flow are almost like the same thing in a sense, because you're going to be passing values around you expect to. Okay, so that's pretty straightforward. How about receiving value from above? That same pass by value approach is actually beneficial for stuff coming to your component as well, right? Like, picture if you could pass signals or values. And this is actually a very important part of Solid's design. This is where we separated from surplus and almost insinuous and almost every reactive library that existed before, and Voby and all of them, is this pass by value mentality is the key to what makes the ergonomics and the DX good. It keeps the principles that we learned from React of this locality of thinking. So if you could pass a signal or value here, like, do you call it a function or not? Like, what if it's a string? You could say, like, maybe you could check it, right? You could be like, oh, if it is a signal, do it. If it's not. But like, picture what you'd have to do everywhere in your, like, picture if like you had 15 props used in a bunch of different places. You'd be doing this kind of check all over the place. This is not fun. You could make a helper function that's like basically like unwrap or something, like basically get me the value if it's a signal, otherwise just get me the value. And I think that's probably the pattern you would use. But like, essentially, like types for TypeScript get more fun. Like, and there's certain awareness of what comes from above they have to be concerned with, right? Another option is you could force them to only be signals. Like earlier we had that question where someone was like, why can't the props all be functions? Well, they could be, I guess. I mean, if you did it in a very non-transformative way and make things signals, like in Solid, you could just pass a function through it, still function, that's fine, right? It's not that big of a deal. But picture view or preact signals, which use .value. You wouldn't want your end user to like have to always like wrap static values in something that's like an object that has a value property on them, or for them to unnecessarily wrap things in signals that don't need to be signals, right? So I do think it's actually very important that you have that mentality of value passed down, and what I say here is providing the same interface for reactive and non-reactive values on the receiving side. Because then you can mentally treat all props as being reactive if you need them to be. If they're not reactive, then they won't update. But if they are, then they can be. You as the component author who decides the behavior based on your incoming props and your state can decide what that behavior should be. But if the person passes you a static value, well, then it's not going to update. So that's perfectly fine, right? In Solid's case, we use prop getters. So I was saying that if you call a function, then we can wrap it in a getter. Whereas if you pass a static value, it's just a static value. We can kind of tell, like, because things that have to be functions or member expressions to call a function to wrap it. If you just pass a variable, we'll pass a variable through. We don't need the extra getters in that case. But now inside our component, we don't care. It just will work. If it's static, well, it sets the title once. If it's dynamic, it'll set the title every time. And obviously using getters has this benefit of they're kind of like semi-immutable, like you can't write to them. So they enforce the first principle. Basically, these things work in tandem together in keeping your mentality localized. So these are basically things, are properties of React that make React so powerful, but you basically get the same effect in Solid or Svelte, actually, if you saw the stream earlier, because like we don't have is signal in Solid. We're kind of like telling people that you can't do this. So like the reality is we want you to just be able to do this and not worry about it. Now you're not worried about what's coming from above. Now you're not worried about what you send down below. You have complete context within the component you're looking at. And as I said, that was the win from React. Could they be interchangeable? Yeah, we talked about it. Signals is standard. There's the potential, right? And which, I mean, yeah, I don't know. We don't know what that looks like, right? Because like we've taken slightly different philosophical things. Like the thing is, you can use Svelte's compiled syntax and generate code that looks like Solid, like because you still need to put wrappers. So like when you use Svelte syntax, you could basically output code like if you made like a custom hook and using your components, that code could look like Solid code. It could use our read-write segregation tuples, right? Like that's like a lot of their examples right now use like getters and a named action, and I like that pattern as well. But like you could use our pattern, because keep that read-write segregation, encourage the consumers of your components, of your custom primitives, to also keep the read-write segregation going. But they do read-write. A get and an increment is a read-write, and in a slightly different form. So yeah, like I could see that side, because like, but on the flip side, like Solid also basically arrives at the same thing without a compiler. And like part of our thing here is like, oh, you don't need to compile all your JS files. So like, I don't know if people would bother. I don't know. So inside of component syntax, works static values. Well, it's not static value. Yeah, I mean, with static values, yeah, exactly. With static values, you don't have to worry about. But if you mean like we do inside the component, you're looking at signals, right? Like I mean, if I go back to the original example here with Solid, where is it? This one. Like in Solid, you see that you have a signal. You do call it as a function. There are plugins that work like Svelte. So like what I was trying to say on the flip side is like, if you like Svelte syntax with JSX, but like their approach, we have tools. So like you can go pick up Solid labels right now and use ruins essentially in Solid. It's already out. So like, I don't know if that'd be enough to put them both together at the same time. It's more like both frameworks have the ability to give the other framework's syntax effortlessly. So it's like, would you bother having both? I don't know. But the reason I'm mentioning this is in the local scope, if we go back to that example that I had with Dominic, I don't think you can avoid knowing that you're dealing with stateful variables. Like, sure, we're calling them as functions, but like the same reason that you wrapped a getter, even though it looks like a variable, is like there's no way to avoid being aware that there is special rules and a data graph on a local scale. You just can't avoid it. You have a language for it, whether it's this or use state. Like there's a language for it. You're going to see that there is these data dependencies that update in a non-standard JavaScript way. Like by non-standard, it's not top down. It's, whether you have an auto memoizing compiler or reactivity or whatever, you're only the things that change update. So if the more you get there with this automation, like what React's looking at, you're still going to locally see the data graph. So like the point is you don't worry about what's outside of your scope, right? So like this, I just want like kind of hopefully follow that kind of scenario here, because like inside you have these state primitives and stuff. Like when you're looking there, there's no way to unsee the reactive graph, at least from my perspective. Even if it's not like reactivity, like signals, you see those concepts of state, derived state, and effects. They're there. But outside, you can trust because of these philosophies. There are limits to this locality of thinking, right? Well, it might be the most, what I consider a very valuable pattern. We can't perfectly achieve stuff because UI components aren't pure. They have state. So while it's not necessary having external side effects, the fact that we preserve references and closures can impact future executions, meaning those executions do matter. That's a really fancy way of me saying that, React components with state aren't actually truly pure. And, we clearly have state, which isn't pure. So like the problem is, even with locality of thinking, we can't control how often our parents call us, right? It's up to them. So on one hand, when you take something like React's render model, you can be like, oh, it's simple. It's local, it's pure input, output. But with hooks, that's not true because there's this actual conditional state that has a previous state that isn't the input or output. Right? There's a difference because of the closures and what runs this time through the hook versus the other time that actually changes what it does. And sometimes we hit performance issues that isn't our fault, but related to something that's happening above. And then we're forced out of this locality. So this isn't perfect. And to be fair, it's not perfect with signals either, because people can over notify. We can have that case like Fabio was showing earlier, in a sense where, we're pulling the value too much, but I'm getting those random changes. But what I'm getting at is, if we pair it with a model that doesn't encourage the parent to recall us as often, i.e. not to re-render us all the time, it does actually help keep our thinking local. I actually think that's the win here with signals to a certain degree, is we actually improve upon that React philosophy in a sense, because we're able to keep the locality even more so, in the sense that, maybe not old React, but React with hooks is impure, and you see that impurity every time you do a re-render. Whereas when you're doing re-renders in fine-grained signals, you're not hit up by that issue, because it's not, the state lives a layer above it. It's not the thing being rerun. I know this is a very nuanced thing, but because the React system has these built-in guards, like we don't change when the value isn't changed, and are finer grained, and so it impacts less. I actually think you can stay in that local frame longer when you have a reactive system than you can when you have a re-render model. But you have different DX signals. Oh, okay, you're talking about count versus prospect count. Yeah, I understand this from a simplistic standpoint. But the thing is, we also have stores, and stores don't call functions either. The thing is, while this is true, there's other impacts of those designs. And one of the cool things here is that stores actually fit more. I have to admit, when I was designing Solid, I was designing around stores, not signals. I didn't think anyone would use signals. I thought everyone would want to use proxies and stuff. But what we found in our community is more people went to signals than they went to the stores. I'm wondering if the Svelte community is going to find the same thing, but I guess we'll see. Oh yeah, I should link this article. Good call. But yeah, what I wanted to say here is, and this is my what I want to say to React users, because I've met a few really, people really into the React mental model, and we have friendly conversations, and I'm like, I'll swing your perspective someday. Maple, obviously big remix fan, and the more I go into these arguments, the more that I feel confident in our positioning in them, because the problem is, back in the day, people remember these reactive systems that shot events and effects everywhere, and things would just go crazy, kind of like a butterfly effect. But the reality today is that when we look at signals, those concerns are basically gone. They've been gone for a very long time. And for me, I look at this as an evolution of components to hooks to signals. And I know that's weird because in a sense, signals have been around longer, but signals and arguably signals applied with React philosophy have been around longer than hooks as well, because solid stuff came out before hooks. But you could also look, this is related to my my diagram over here, about people kind of jumping off the tangent here, because if you look, sorry, wrong one, this one. If you look at it, here, components are your whole world. They manage your updates. Here, we have a more granular thing, but it's still components that update, but you have a more granular way of controlling the change. And this one is taking that hooks and then making the components not the thing. So it's it is really a 1, 2, 3. But it only works if we maintain those React principles. If we're passing signals around and stuff, not making them unidirectional, then yeah, we're back to knockout in the chaos of the past. You're right. There's a reason why Solid doesn't have his signal, or Svelte ruins don't let you assign signal to a variable. You don't want to worry about the data graph outside of your view. Inside, as I said, I don't think you can avoid it. JavaScript doesn't have automated granular updates. So even if we try to hide it with the best compiler you can imagine, with automated reactivity or memorization or whatever you want to call it this week, you still need to have a language so you can see what you're doing. It's the same reason in that proposal I wanted the imports. You need a way to tell the developer what they're doing. State. Effect. So I don't think there's a way of escaping it. Even when React, realizes and goes, look, here's forget. It does all the stuff we're talking about. It's not actually effectively any different than Solid or Svelte in this case. So maybe everybody's going to be essentially on the same page. Because the common ground is if you treat everything as reactive, that could be the burden of the decision of what is reactive is pushed up to the consumer, regardless of whether you're dealing with simple signals, nested stores, primitives passed from props or coming from globals or whatever. Because you just behave the way so you allow the change to happen. Whoever owns the state, like the consumer, the person who calls your component, the one passing the data down, they make the decision of what is reactive or not. And by making your model that way, it's easier to actually author the components for the people authoring them because they're not like checking signals and stuff. They have their locality, so they're worried about making their stuff update. And for that consumer passing the state down, you've completely unburdened them and you've given them that confidence that they can make the right decisions. So that is why this is so powerful. Yeah. Anyway, I think, yeah. Comment here, InfernoJS is utilized, but it's kind of boring. What's interesting is a full cycle from event to DOM render. It's MVC framework. People forget the origins. That's interesting. Yeah, I don't know. Sorry, I was reading that on the stream. I probably should have read it out loud. It's talking about MVC versus unidirectional and saying that React is just an MVC framework. I feel like maybe you could argue that I could see that how it was that in its origins back in the day, but I have a hard time seeing like the modern React hooks as an MVC framework. Flux being a pattern for global state, I guess, is the key for them because their state's owned by their components. But what's interesting to me on the signals, which I didn't talk about at all in this article, is that with signals, this kind of doesn't matter because it's all the same mechanism, whether it's local or global. So these philosophies that I talk about here, these principles that we learned from React, apply universally. So yeah, I like this framing. I don't know if everyone else will. This article is not terribly popular at the moment. Ever since I lost my Reddit retweets, we can do good on Twitter, but I can't get this. I don't seem to be getting the same audience on my articles recently. But I think this is really powerful. I think this is actually as a React developer, I find this the most compelling because I think this actually shows how this doesn't only address the concerns that people have had historically with signals, but actually shows how it embraces React's mentality and maybe even takes it further to the point that it's almost like the future, like forget's already here. That's my opinion. We'll see if that holds on, but yeah. Anyway. I think that's it for today. Someone said Fresh 1.5 came out. Let me see if I can find it. Fresh. There we go. Partials allow the server to swap out parts of the page. Okay, so that's cool. It looks like they may have finally added something like our router, or are they doing stuff like HTMX? Let me see what this is. Okay, so this is, I'm gathering their server component like solution. So this, I figured this was like the router we built in Solid. This does remind me of Solid's Islands router. That is very cool. Let's see how they use it. Oh, okay, they just name it as a partial. That's interesting. Okay, and it works the way Solids does right now. It literally renders the whole page on the server and then replaces the pieces. Do you know what the problem is with this? The state preservation problem. But I see what they're doing. They're doing it like a slotting mechanism. Yeah, the only thing that's weird about this is the client feels like the client's defining the partials. This kind of breaks. But if they're not word with state, maybe this is fine. The rules of server components and islands are there largely not just because of the prop waterfall thing, but it also lets us optimize the double data problem because the data isn't necessarily necessary in the client for hydration. When you start putting server components inside client components, and because of the ability to relink the link there, you can't actually make any of those assumptions to drop that data for serialization. So like double impacted here. This feels like it's HTMX inspired, but I'm not sure if this is the right direction. I understand that in a sense it's simpler than doing server components, but I'm not sure what this actually gets us. Oh, shipping with view transitions, yeah. Yeah, and this is kind of like where Astro is too, but it like, you got to solve the state problem. Why? Sometimes it reminds me how far ahead React is of everyone else. Keep on using React, guys. React is light years ahead of everyone else. I mean, I'm glad there's more exploration going on in this zone. I can understand why we want to do everything possible to avoid like the complexity of stuff of RSCs, but I am completely sold on, even if the React implementation is not great, even if the design APIs around them React are clunky than they need to be and kind of suck from, not suck, but like they've never sat right with me. I think they're solving the problem in like a conceptual level in a good way. React is light years ahead of React. Yeah. You know, this is going to be an interesting time. We have Quick on one side, we have React on the another side. The stuff we're doing with Solid, kind of like hybrid between those ideas. We have Astro kind of like on another side, on the other side of like the third pillar, Fresh kind of sitting by them in between us and Astro. Like there is a map forming here of these different solutions. It's just time to thread the needle like we did before with Signals and show people what this is really supposed to look like. Sounds good to me. All right. Yeah, no, it's too late for Excalibur. I got to wrap up. I got to have some dinner here. But yeah, it's funny. There's this tension of why anyone would use React. But when I look at the way React thinks or approaches the problem, I think they're like mostly right. They're just details, but like we're gonna have like a bunch of people do stuff that just misses the mark, but kind of does good enough until we realize those shortcomings. I think React maybe overthinks the problem, but like they seem to come to what I feel like quite often almost inevitable conclusions. Why wouldn't anyone use React? Well, I mean, that's the other side of it, right? This is a much more common take. I think there's so much potential to outshine React today, and that's why people are trying a lot of different things. because we're working on features that people don't even realize they need yet. But yeah, I hope when the dust settles, we can have a consistent story where we can be talking about these things in the same light that I talked about thinking locally in that article, where we can see the emergent patterns winning in terms of the overall benefits they bring rather than the specific target or even the mechanisms, because the frameworks are more than the mechanisms they have. They're the ability to provide us with that consistent mental model, our ability to be a framework, for the mind, as Rich Harris said, as much as for our code. So yeah. You guys are hilarious. I'm not getting into a React versus the world conversation right now, but I feel like islands and server components are kind of this weird, or server components especially, this place where there's kind of miss. A bunch of people thought they were designing server components for their frameworks, and instead they designed lakes. Lakes are not server components. They don't carry any of the benefit. Islands are, but people coming from a client-side mentality always start with lakes for some reason. And it's unfortunate because it's like lakes are like a stopgap method. They're not going to be where things head, in my opinion. So, oh well. Yeah. Anyway, I've talked enough. Stream's 5 hours and 20 minutes. I am well past done. I hope you all have a great weekend. Thanks for joining me this week. Next week, we're going to have Michael Rawlings from Marco. Also, thank you, Mitchell Stoon, for tier 1 sub. I haven't been very good at keeping up on the subs recently, but I appreciate it. But yeah, more great content coming next week. And see you all then. Yeah, more Marco. All right. Bye.